Start soon. Start. There we go. Oh, everything's a mess. We're going to try to do Circuits book today. I'm not muted? I'm not muted. I just put a thing of... God, I don't even know what it was. It's just Italian food that we got delivery last night. Super salty. Put it in a piece of bread. Ate it for lunch. We'll see how that does with my glucose levels. Being all sensitive. So about this lock. I'm pretty sure I identified it. It's nothing as complicated as people in chat were saying. It always bugs me when chat gets way ahead of me and starts trying to sound super smart. It's like, we know you're smart. We know you guys know about lockpicking, but we're not dealing with super lockpicking stuff. Hey, how's everybody doing? Remdog, Bring GG, Twitch Microwave. People get in here and they want to show off something that they know about. So you've been watching Lockpicking Lawyer for a million years, and you want to show off that knowledge. And it's like, I have the simplest of locks here. That's just literally a thing that goes up here, and there's a little, like a little drum thing that kind of moves this way out of the way, right? And so you have to say, well, this is that unpickable lock with the rotating cylinders and blah, 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 blah. And it sets me off in just like the worst direction, right? Bought a lock repair set on Amazon 6 years ago, so clearly I'm a lockpicking expert. That's actually what I think I need to do. I think I need to buy again, because I don't know what happened to my tensioner or the rest of these lockpicks. I think they ended up in a drawer somewhere, and then they were jettisoned into space at some point, because I don't see them nowhere, and I don't know where my tensioners are. I used to have a bunch of tensioners. I think I got rid of some, but I need to get one of those kits that comes with like the lock. They're like 20 bucks. They're not expensive, but I thought somewhere in this tool chest I would have. I don't know. They're not in here. Big ups, John B. Doing a YouTube stream. Thanking his patrons and whatnot. Big up. I haven't seen Gonad in like 4 days. I hope he's alright. I think he's alright. I think he's fine. I just haven't heard from him in a while. Maybe he's actually sleeping. For once. Sorry, doing a really protracted, fake, stupid British accent made me think of him. No, don't summon him. Don't summon him. Don't do that. Don't do that. I'm sure he's fine. Where the hell are my tensioners, though? I don't understand. What did I do? These are all cloths. Yeah, it's just like they don't exist anymore. I don't think I would have gotten rid of them, but maybe I did. They're probably in a bin somewhere, right? Bottom of a bin. Like, oh, I'll put all my lockpicking stuff here. I don't know where they are. Well, that's what, I mean, I was looking around at what I could use, and some of the stuff I have is too thick to go into these. This mix might not be working out. Hold on, I need one where he's quieter. John B, shut the fuck up. I'm trying to stream with your music. Much love, massive, etc. Jeez, sorry, a little neck-breaking camera work. He's having a good time. Where is this window? That's not the window. Oh yeah, I need to actually start up the YouTube chat and make sure. I'm picking up the hype train. It's not my hype train. It's not mine. He's much more popular than I am. What up, Madam U? I missed that comment, but we got it now. Participants. No. Pop out. There we go. I don't. Okay. All right. No. SoundCloud, maybe? Just anything? Oh, these are individual songs. I don't want individual songs. I want a big mix. Blue Note set. Live at London. There we go. I guess I can't do this without subscribing. Yeah, we're not doing that. Get out of here. We'll start from the beginning. There we go. John B. Everybody check out John B if you get a chance. If you haven't heard of him, you haven't been around. Back to what you guys are saying. Wiper blades, yeah. No, no, no. I was talking about what a funny way to clean solar panels, and to be honest, the point is, like, twice a year you could just go out with a hose and a pool brush and clean them off. That's not hard to do. Or you can get a ladder and you can climb up to the roof and you can scrub them to your heart's content. It does not require a massively automated solution. And a lot of the things that Discord's been doing lately, especially around me for some reason, maybe it's just that we have inane ideas like this, is that you guys go off on these long, just crazy ideas that are just not necessary. Like, I don't know, Copper will pontificate about an idea and nobody asked. It's like everybody's around there like, why are we talking about this? So it would be funny if you had to clean your solar panels, if you had like 15 wiper blades that would just windshield wiper blades that would like wipe across the solar panel. It's totally impractical and stupid because you could just go out there with a brush. I know, yeah. Oh, thermal shock? I don't know. The glass should be a little bit more steady than that. People have done little spray systems, but the problem is the crud that accumulates in the Northeast, at least, can be very stubborn. It can require you to actually hit it with something that will make it break off. So I don't know what I can use as a tensioner here. I don't know where any of my supplies in this regard have gone. I remember that I had a whole bunch of lockpicks at some point. That were these. These came in a massive kit with a whole bunch of stuff and a bunch of tensioners and stuff, and I don't know what happened to it. Let me go look at my other toolbox. Hold on, I'll be right back. I have a spillover toolbox in the other room. The BRB. This guy. Hmm. There you go. I'll be right back. I found one weird thing. I don't even know what it is. The hell is that thing? Some kind of weird tool to do something. I don't even know. I think I might know where some of them are. The lockpicks, that is. Are they in here? The forbidden drawer, the one that you guys can't see. The glasses repair kit. LDS. HP mouse. None of these are lockpicking stuff. I had all this stuff. I did. I thought I'll never use that. Then this happens. Yeah, it's not in here. This is some hard-hitting stuff, huh? Okay, no lockpicks in there. I'm just looking at the various drawers that I have to see. It's a doodad for turning thingy-mabobs. It's... You're not wrong. Actually, you know what? It's a valve stem tool. I happen to know. Suddenly I know. It's a valve stem tool. Hey, Pyro, you're here early. Yeah, this is for bike valve stems. I don't know why it was in the drawer with all the audio cables, but it also has featured a little piece of metal that poked into my skin, which is always nice. I always like getting tetanus suddenly. Yeah, it was what tipped me off is this is the French valve stem tool. It's the little pole with a little split in the middle. So I don't know where it came from. We'll go back here. Where did my picks go? I had a whole set of these things. Never got to use them on anything. This happens to be like a 5 to 7 tumbler pick. Dang Frenchies. The French valves are good. They're pretty good. But like, I think this is a 5 tumbler lock and it's nothing complicated. It's very, very simple. Very simple. Pick the lock, get into the phone, simple as. The only problem is I don't have a good tensioner. I don't have metal that's thin enough that I can cut to make a tensioner. I can use a pair of tweezers, and we can see by the way this thing moves how it pivots here and makes a tapping noise up here when I touch it down here. When I touch it up here, solid. So I'm thinking that there's a little thing that goes up this way and a barrel up here that needs to go out of the way in some way, shape, or form. Drill it out. I don't want to drill it out. I guess a paper clip could also tension. I was using these earlier. So this has to go this way. And then I can get to the barrels this way, but I can't really get them to stick. So I don't know if there's extra features in this. I don't know if there's extra features. Like if I could just get it suddenly. Yeah, I don't know. It's not budging. More tension. I was giving it a pretty good go. Yeah, if I could just find the proper piece of metal to alter. But I don't want to like ruin all my stuff. My stuff. It should be like this. Break out the drill. You know, sometimes they put stuff in locks to keep you from drilling. This is the only pick that I can actually get into it too because of the way the key is shaped. I don't know. I don't think any amount of raking is going to do it right. I'm not going to drill it out for education. Picking it would be the more educational thing. It's just none of them are sticking. I'm not getting any movement in the barrel. Oh yeah, apparently there's zero chance I'll find a key. But that's in the more complicated payphone locks. This is a very simple one. I think this one was on private property because it seems like a lot of the stuff, like, first of all, they got rid of the really secure lock for down here. It's the upper lock is a lot less secure in many cases. And then looking up any information about the lock, there are no markings on the outside of this, and both faces that I can see are brushed stainless. And so the lock that I've been able to find that is similar to that looks like, if I have Discord open, like, everybody's overcomplicating it because they've watched too much lock-picking lawyer. Everybody thinks they're super expert in locks, and it's just not that complicated. This thing is this lock over here. The problem being that, first of all, this is a 6x6 pixel image, but the other part being that I'm just not good at picking locks. I've had lock picks for a long time, and I've played around with them for a long time. I'm just not that good at it. But everybody thinks it's like the tumblers are tilted a little bit, and maybe they're the ones that you need to tilt into a particular position, and then you need to do this and that and the other thing, and blah, 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 blah. Now, look, man, I'm not good at locking picks, and this is what we have. This is the brushed on both faces. It has that little kink in the top face of the key there, where the I guess it would be, yeah, whatever. It's the little, like, that little tilt in. Everything about it just looks the same. So that is not a complicated lock. That looks like it has 4-ish positions that it needs to get to. And it doesn't have any of these fancy schmancy lockouts that everybody seems to want to just talk about because they want to seem like they roll hard with locks. Yeah, but I don't want to break my phone. This is my only phone. And I got to call my mom. You want me to not be able to call my mom? That's the wrong way. We go this way. I've been at this for 2 years and I still make multiple minutes to open door locks. Yeah, seriously. I had a okay, so the NRA. I do not support the NRA. I think they're a bunch of weasel fucks and they can go fucking suck on shit. But they had a really nice shooting range, and I was in Northern Virginia. So I had a laminated NRA range card in my wallet. And while I was working for the company in Philadelphia, I know I need to flip it around, but it's the only way that I can, like, hit all the tumblers properly. But so what I did, a coworker locked their lunch in the conference room. And it was an old building, and it had these big gaps in the doors. So I took my NRA range membership card, and I broke them into the room to get their lunch. That's the high that I'm going to be chasing for the rest of my life in terms of being able to get into locked things, right? This is not. I don't know how good these are. I know. Drill it out, flip the pick around. What I'm doing here is I'm putting them up to their maximum point by flipping this around and raking on the back of it, so that I push them up to the maximum and let them fall back. And as they fall back, I'm hoping to catch one. But it seems like I can't catch a single one. Open more server room doors with a credit card than a lockpick set. Don't ruin your credit cards. Mine no longer scans, not because of lockpicking, but because I just getting into doors. But like mine stopped, the antenna in it stopped functioning for some reason. Oh wait, you know what? I actually have a new credit card I need to activate. I haven't activated that in 2 weeks. ADHD. Good old executive misfunction, huh? Yeah, it's this carry expired one specifically for that reason. Oh, that's the way. That's not moving at all, and most of it is my problem getting. Like, I can't, the picks that I have, like, for instance, of the 3 that I found, I don't know where the rest of them went, I can't get this one to hook around a barrel because I can't get it to traverse from this chamber to this chamber. This is a very bent lock, or a very bent key. I can kind of feel it out, but not really. Plus, I should go way deeper than this. It should be way deep, like there. So let's find the first one. Let's find it. Fucking, god damn it! Make the picks thinner. No. Well, I'm on something that's sprung. You get sprung. So if I can get the tensioner on that. My theory is that it moves this way, but I could be wrong about that, because I thought, because when you tap this, you hear a tapping noise here. So I thought that it was exactly like the image, because it looks exactly like the image. All the squigglies are pretty much exactly the same. This is the only image I was able to find, and it's 4x4 pixels. But I like big phones, I cannot lie. You get springs. Okay, so yeah, so I'm pretty sure that's that, but I don't know. What direction is that going to move in order to disengage? Probably going to go to the right. It doesn't have enough room to swing this way. Maybe it does. Maybe it just moves a little bit out of the way. I don't know. John B., set me straight on this one. Beats to break into phones, too. We'll try going the other way and just see, because it rotates a little bit in that direction. But then I need to be able to feel... Where is that? Now, it felt perfect before, and then I let go. Quarter turn, yeah. Something small. What the... Jeez. Yeah, it's these picks are just small enough, but they get caught up on the zigzag. Yeah, that's what I'm doing. That's what these are. I'm putting these in the keyhole, and I'm moving the keyhole. Yes, thank you, chat. Thank you. I still don't know how many things there are in this. I think 4, but it could be 5. That doesn't look like there's... It looks like 1, 2, 3, 4, maybe 5 and 6, but not really. Seems like 4 positions on that one. But like, theoretically, I should be able to at least get one of these just by harassing it a little bit. But I can't feel where that second thing is. I don't know where that is. Well, model phone? I don't know, actually. It's a relatively newer phone, and I'm pretty sure this is in like a mall or something secure, because like not a place where you're gonna have crackheads trying to break into your phone, because it doesn't have super duper locks on it, right? I don't know how to identify. There's probably ways you can identify it by like, because this is a relatively newer design. This sort of type of, why is that all fucked up? Yeah, it seems like I need to like mess with stuff inside to kind of fix it. I wanted to hang this up on the wall right next to my computer, because then I could do a phone bit where I pick up the phone and it'll distort my voice as like the, you know, the low quality phone bit rate. And then I could maybe make these do DTMF. I could also make them do sound effects if I really want to. And then I'd be able to slam it down really hard and make a nice loud bang. I don't want to drill it. I'm not at that point yet. You go get your own phone and you drill through your phone. You drill through your cell phone. I'm not gonna drill through my phone. We're not even doing this today. We're doing the Big Book of Circuits. I would never ever allow you guys to call in. No. That's just, let me just put my foot down on that one. Let me just put my foot straight down on the ground and say absolutely not. The last time when I did Amogus, the first time I did Amogus, somebody joined that chat. This is before we did the chat airlock thing. I did Amogus, and I start my stream, the first time I ever had interactions with chat on voice, and somebody joins in and starts saying the N-word on repeat, because it's the internet, I suppose. And I had to nuke the entire 5-minute session and start over. So no, I will not be taking calls from chat. Thank you very much. Yeah, just go ahead and ban me ahead of time, because some Yahoo is going to jump in and ruin their account. It's like the time I showed Discord for 1 second on chat and somebody posted a bunch of not good, it was actually pretty shitty interracial porn on my Discord's main channel. And he was like, see you in space, cowboys, or some other stupid fucking line that made him sound like he was super cool before we banned his ass and deleted all the images. And then chat was like, no different from when it started, because my Discord is so small. Like, what do you think you're doing here? I'm not PewDiePie. I'm not that popular. I'm not even worth harassing. The fact that this thing moves so much in and out is so weird. It's like whatever the panel mount is on this thing, they just didn't tighten it all the way. If I keep doing this, maybe it'll fall out. That appears to be a Frontier payphone from the 1970s. I don't think so. I think the 70s is giving this thing... This does not have the grime of being a phone from the 70s. And it's a Verizon phone, but there's no identification markings on any of it. I don't think we're talking 1970. This has a very 80s kind of feel to it, to be honest. 80s and 90s. Verizon and Frontier are the same company. I didn't know that. I don't know what that is. Groza! Adrian, just found your YouTube channel a few days ago. I love it. Hey, thanks. I'm very like I don't know how to feel about all of the like the VODs going up because they're Twitch moments and they're pre-recorded, but like YouTube likes their edited content, you know? And like this stuff is like raw. This is me failing at a lot of stuff. There's a lot of projects that are going on at the end of 2022 that don't come to fruition, and they're still not done. So it's getting into that stuff, and I kind of have to stick my nose in that puddle of piss and deal with the consequences of my own actions. So thank you. I am glad you found your way here. The algorithm loves the fact that I'm doing daily uploads, and there's about 130 left to go, and then I'll be done. And it seems almost to be tracking real time, because I'll do a couple days where I'm able to upload like 6 videos, and then life happens, and then I end up, like recently I was on the cusp. The last video that I had uploaded published that day, and then I uploaded 3 more. Like I can't get ahead of it. I should be months ahead by now. I just can't get ahead of it. Sometimes the video only has a couple chapters, and sometimes it has 10,000. And I want to keep those chapters in there so that people can jump through and give me that credit for them watching, and then jump through the parts that they don't want to watch. But other than that, it's just a big archive effort. And I don't know what happens to the streams that are up on YouTube in the live section once I get done that 130. Maybe I'll take a little break and then I'll come back and start publishing those leftover ones until we get to present day. Maybe. I don't know. It depends on what I can tolerate. But at that point, what I'd like to do is figure out video editing software. What video editing software can I tolerate? Do I use my ancient copy of Adobe that my buddy Matt gave me, or do I do like some other like DaVinci or whatever those other programs are, and actually start cutting together videos and making a whole bunch of e-waste both on my local computers and on YouTube that will just fester in its ancientness until the bit rate gets crushed into nothing, and we all become the compact soil under which the new generation of YouTube exists, of e-waste. They'll find our plastic in their bones and their blood for years to come. Our e-waste microplastics. And hopefully, at some point, it can make an AI start a fire trying to fix something. It'll draw on some little nugget of information that exists in my streamosphere, and that will cause it to reverse the polarity of the ODN network and blow up the Starship. That'll be pretty cool. That'll be the day I shine. GTE Quandrum, they put an R on there, really? GTE Quandrum 120, A, B, or C, manufactured between 1970 and 1989. This thing is really that vintage. The ANC models are determined by the push buttons used, with the C variant being the most popular. The push buttons. The buttons. Big up to the buttons. Well, we have the Loudinator. Loud, 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 loud. Noise, noise. Operator. Noise, noise. Operator, noise. Noise, 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 noise. Operator, noise. Noise, noise, noise. Okay, I'm done. AIs, but yeah, I made that joke yesterday, and I think 2 people got it. But then the news article became much more popular. Apparently, Google's AI has been scraping Reddit and telling people to fucking throw themselves off bridges, as well as using Elmer's glue or some other non-toxic glue in pizza to help keep the dough on, or sorry, keep the cheese on. Keep the cheese on. Okay, where was that link? I'm gonna open that up. Let me take a look. telephone world. See, the problem is I buy this thing for a bit, right? I buy this phone for a bit, for just like a little comedy bit that I thought would be really funny, because we do hardware here, and having hardware to do a funny little phone bit instead of, you know, my mixer that already has a built-in like telephone sounding thing. I wanted to have the genuineness of this thing, being able to slam it and being able to make it ring. But then I buy something like this, and people come in who have been into payphones for 30 years, and we have to sift through this kind of stuff where it's like, oh, that's this specific. I know BrinkGG's is looking it up, obviously, but like you get this kind of stuff. It's crazy. What is that one? 3 different models of metal touch phone tone keypads. On the right, model 120C, 3rd generation of square buttons. That looks about right. But it's the sort of cast metal look. Huh. Coke use. Not all AE Quandrum payphones were created equal. With the breakup of the Bell system, Lucent Technologies, this allowed businesses to own their own payphones. The AE Model 120 was easily customizable, became a cocotte with the replacement of electronic boards inside. A number of phone companies also modified their existing payphones to become cocotte. Here's an example of a cocotte AE Model 120. Wow, so many pixels. Thank you for this wonderfully detailed image. That does look exactly like what we have, though. That does actually look like exactly what we have. And there's the missing key down here, and there's no keyway on this side, and then this comes out the side like that. Yeah, that's probably exactly it. Ours just looks a little bit less glossy. Here's what the insides look like. This is a rotary phone thing. Wait a minute. Well, the link is at the very least. Yeah, looks about right. Yeah, see? Barrel going up. So maybe it does go to the right. There's not a whole lot of stuff going on in there, huh? Guess it's all in the handset. It's funny, that other cell phone we saw was much more complicated than this, but it does look like there's a big mechanism that undoes all of these catches all at once. Does the right and left side should yeah, it looks like they go on their own. They all are connected. I don't know how they're doing it. There's probably some kind of a push rod or something on one side, or a shaft of some type. But yeah, this is where we're looking, right here. You guys can't see any of this. I'm on the wrong stream, wrong channel. Sorry. Wrong one, wrong one, wrong one. How long was I on that one? Nobody could see a goddamn thing. What's wrong with me? So yeah, we were looking at, I don't know when the stream switched, but this seems to be it, the Model C, because we got the Loudinator button on it. And then I read this paragraph and I was looking at this image that had no pixels on it at all. Sorry, you guys missed that whole, I hate it when that happens. You know, I'm looking out of the corner of my eye to see the other image, but yeah, this is the inside of it, and there's a mechanism in here that is flipping this. Oh, here's the bigger one. So this is the mechanism right here. This is what I was talking about. This is the key that we're trying to unlock. Where's the coin mechanism in this thing? I guess it's up here. Oh, really? They all have the same key? What's the... Meanwhile, people were in here telling me about all of the complicated locking mechanisms that I could be up against, and yet this is just a super... It's like a key, like an electrical key switch, where they have one model of key. So, eBay... 120C key. Toolbox key. None of these are the right thing. Payphone key is all kinds of stuff that comes up, so. Yeah, there's some very common keys. The electrical key is the funniest one of them all, because I've had 2 electrical key switches, and I was like, wait a minute. I just tried any key on it, and it just works. It's literally like the least amount of lockout. Oh my god, this is a big link. You can delete, you can shorten those a little bit by everything after the item number when it gets to the question mark. So all I need to get is, where is that? Bobbity-bobbity-ba, all the way up to, but not including the question mark. And I can just put that in there as a nice short link, and it'll come up. Medeco BJ 00048 Electrotel Protel GTE Palco Quandrum. I ain't your Palco. I ain't your buddy. Friend world. Yeah, there all is to it, huh? You're saying they're all keyed alike? That seems a little wild. It's like I don't know if there's 1, 2, 3. That's what I'm saying. It's a very low security lock. How to pick any Medeco lock? Oh. Why, that name is very awkward. They need a better name. Oh, yeah, this was the one that was sent to me with the tilting action in it. That's not what this one does. This doesn't have the cross cuts. It's too simple. Yeah, I've been watching that other video. That seems like a huge pain in the ass, but that relies on cross-cut keys. It's a weird system. I do not think it has that. That looks like very straight cut. Brute force it with an impact. I could do it with like a lock-picking gun if it would fit in. This is the thing. That's the thing. It's like, this is not complicated. It's not a complicated lock. I can pick this. I'm just bad at picking locks, and you guys get to deal with that. I'm not an expert. That's the YouTube link from what you were looking at. Let me see. It's the same thing, because I have watched this video. I already watched this video, but it's not the lock. It's like somewhere around. Oh, that looks very, very familiar, actually. Wait a minute. Yeah, this is the kind that has these. See how these are angled? That's how it does the twisting of the cylinders in order to get it, right. But I don't think that's the kind of lock we have. It looks very similar, but it's also shiny, and ours is brushed on both surfaces. I just got scammed. I ordered a $350 car bumper, and they sent me a flower. That's no good. That's no bueno. That does look very familiar. That does look very familiar, but my hope is that we don't have that type of lock. Well, that's the lock, but so is this. And this one isn't the tilted. Yeah, maybe it is. Maybe I'm wrong. I might be wrong. And if it is this type, I might as well just fucking like bust it with a drill. Am I wrong? The answer may surprise. Yes, the answer is yes. What a piece of shit lock. Total ass. And then there's that from the side, and then you can turn it. Damn. 3D print a key? Maybe. I don't know if my printer's that good. I'll have to watch this video, because this video seems to go into much different detail about the thing. I was jumping around with videos and looking to try to see which one represented the lock, but resin printers are preferred. Well, the resin printer project is going to be its own thing. I don't know. The simplicity of the face is very similar to what we have. I have 2 brushed faces on the outside. Oh my god, my eyes. This is just us kicking around before stream, just hanging out, right? We're not committing to anything right now. Brushed surfaces on both, and that may just be a matter of which one you order. But all of the subtle details, the chamfering, the inlay. Is that eggshell? Let's see Paul Allen's key. I don't know. If it is this type, it's going to be a major bitch for me to be able to pick. This guy's pick just goes right on in there, huh? Mine ain't. Mine's a lot thinner than that. Oh, look at you. Oh, yeah, I unlocked it. Bitch. I hate this guy. Yeah, so if it's that type of key, or if it's the one I found, or this one is Palco Quandrum. The specific models are keyed alike, but the A versus B versus C keys are different. The reflections on the thermal. Yeah, the thermal, if it's metal, like bare metal, long wave infrared bounces off of it like a mirror. What is in a lock? Oh, there's a lot that goes on. You guys can Google it if you want. And then all the same type ID lock. Well, payphone to payphone, probably not, depending on who owns it and decides to put the key on it. It could vary. And of course, the eBay auction did not come with a key, which is the fun of it. Yeah, so if it's this type and it flips away like that, the GTE Quantum Model C, the 120C payphone, regular square metal keys. Huh. Honolulu Airport of the flush-mounted one. Huh. They mounted it to flesh. I was thinking it'd be like this one, where it's just got a very simple key, and this is the only one that I found that is brushed on both surfaces, like the one that I have. No, it's not as simple. If it is the type of lock, the Medeco lock requires that you have slants in the keys, in the keyway, or whatever, not the keyway, but the slants in the different locking in areas, because you have an angle and a height, two different things going into what makes this thing work, and what keeps me out of it as a very amateur lockpick. You do this stuff on Twitch and it's never satisfactory for anybody who's watching. They all get mad at you for some reason for doing your best. But I thought it was a simple one, but it looks like it might not be. It might be like this. I know more reason to drill, but I don't want to drill it. I can get this. You know, it's going to push me in a way that I don't want to be pushed, but anyway, I'm not going to sit here on stream and just have doing this. I'm not going to do this all day. We need to build up our confidence in being able to do projects, because I haven't been able to get fucking anything working. I haven't got anything working. $25 to get a new one with a key. Yeah, I know. But if I drill it, what do you do when you drill a lock? Do you drill straight through? Do I just use this, or should I punch a hole right above, you know, so I'm going through all the tumblers, and then I drill straight in that way with like a big one? Or do I take an end mill and just render it into nothing? Start small and size it up. Get flyered up. Start small, so you have a piece of a broken drill bit inside of your lock, and then go larger and larger. I know I'm not supposed to store these like this, but these mostly aren't mine. These are dead guys' end mills. I just take the most coated, strong end mill that I have, and do I do like a payday with it? Do I have to set up like a magnet drill on the outside, and then when it gets stuck, I have to call my buddy and they have to hit it? High speed steel. I don't know. I don't identify that. These are just my end mills. I'm just grabbing these because it's funny. Just like shove this thing into its patootie. Oh, that actually I put scratches on the lock with that last one. Huh. I didn't even press it on there hard. I'm not gonna do this. I'm not gonna do this. This is the last resort. I don't know if I have high-speed steel drill bits. I've Amazon Chinesium special stupid drill bits. So who knows if this will work? Full speed, straight down in the mill. Ugh. That was high speed. Okay. I don't know nothing about nothing, chat. I don't know nothing about nothing. Hey, in a couple weeks, like after June-ish, when we've got some numbers going on in June, I think Julian's going to be able to come in here with some synthesizer stuff. So I do want to get ahead on some of those synthesizer things. This is the fun one. This is just some plate metal wrench that was given to me in some stupid thing that I bought from China, and we just put that into the milling machine and made the T-key, which you can spend $10 on, or you can just make one. Don't use carbide for your first hole. Is that in case it breaks and gets stuck? Because, I mean, these guys are going through the trouble of making their lock have to have certain angles on the individual tumblers, and then other people were telling me that some locks actually put tungsten inserts so you can't drill them out. If it breaks, you're done for. I see. You're gonna be sorry. No, yeah, there we go, secure. It's a lock, it's not 4 locks. It would be designed so that a key is lost. Any locksmith could drill it. I guess. I mean, yeah, have you seen some of the things these locks are doing? Lockpicking Lawyer had a video that I saw where the lock itself, if you try to pick it, it will drop these little pins down and keep you from turning the lock ever. So you have to go in from behind and break the lock down in order to use it again. That one could still be drilled through, I guess. It's so weird. It's like somebody tried to pick my lock. It's like, where are you that you expect that to happen when you have windows? Like, you have windows. Your house is made out of drywall. There are easier ways to get in. Not everybody's going to spend the time trying to pick a lock. Unless it's like fucking espionage. How paranoid do you have to be? Move into a house in the woods. Nobody gives a shit. Put a camera up. Yeah, somebody tried to pick my lock. Now I'm stuck out here. Not in my house. Wait a minute. I didn't think this through. Yeah, I gotta be a special kind of paranoid. Although I think the lock-picking lawyer probably has it in his best interest to use something like that, since he is the lock-picking lawyer, and you know, crazy fans will be like, I have to prove myself to lock-picking lawyer by showing up in his bathroom in the middle of the night. I'll use my best lock picks. Ah! This thing is really heavy. It's not that bad. Classic John B. All right, let's get partial started here. Get the music out of here. Everybody check out John B and SoundCloud and in his house. Break into his house. All right, I'm gonna fade out the music very subtly. There we go. Why is my mouse caught? There we go. Jeez. Suddenly I can't operate my mouse on all 15 of these screens. Hi, how's it going? So, welcome to Friday. We tootled around the phone a little bit for the pre-stream, which is always fun to do. I kind of want to pick that lock. I don't know if I'm going to be able to. It seems more and more things are pointing towards it being the type where the individual pins have to pivot into a certain position in order for it to release, which is an oddly complicated thing for a payphone. But I guess if it's sitting in public, you want to keep people from being able to easily pick the lock. It's possible that I could pick the lock. But there's some things that keep me from doing that. I'll drill it if it comes to that, and it's getting closer and closer to it seeming like I'm gonna have to drill it in order to get in. But I mean, I could even throw it up on my overzealous drill press. It's a mill drill, less so a mill and more just a drill press. But I could put it up on the drill press, throw a bunch of oil on it, and just until it opens. That's a little anticlimactic for me, though, because I'd rather have something that I can tinker with. So I'll tinker with it a little bit more until I get super duper frustrated at it. The real lock-picking, like Galaxy Brain people are able to find those individual pins and feel the tilt. Although I don't know what you do past that, because there's other stuff in that lock, supposedly, that keeps you from releasing it when there isn't a key in there. Although I got to watch that video. I got to watch the video FK linked me, because that seems to have good information, and they look like they pick the lock. I don't know if they actually do. But I want to try my hand at picking the lock, because it's like a cool little puzzle for me to solve. And then at some point we'll get to making that into my simple little phone bit box where I could pick it up and talk in a distorted way and then slam it down the receiver. Anyway, I've got a bunch of like crazy unknown projects that are on the way, but it's Friday, and Friday we have Big Book Fridays. I got this big fucking book, chat, and it is from 1974, and it has circuits in it. Although we're finding out a lot of the circuits are small pieces of a much bigger circuit, so us sitting down in the lab building these things, we should be able to build a bunch of cute little circuits that do stuff. We haven't been able to do that, and I think we really need to find one of these circuits that builds our confidence. I need something that'll work today that we can put together simply. We got to a point with Dave's synthesizer where I'm waiting for parts, because I could just plug it back in with the right chips on there, and it might actually just work. We got trickle down word from the creator of the module through Chatter Ben Gizmo, who knows a lot about this stuff and apparently knows that there is a PDF site circling around somewhere where the 4 components that blow up when you plug in the synthesizer backwards, these 4 components are typically 90% of the time what dies and kills the synth. So now I can replace those parts and be done with this. We still have the schematic and everything in the M303 though, so I could maybe build my own at some point, but I'm really desperately trying to clear the table because I'm trying to get Julian and Dave in here, and I'm trying to get projects done, and I'm trying to build their confidence. We need to get stuff done. It's hard to have a panic attack because we got to work on Burn the Subs. That shouldn't be too far along in terms of what we need to get done to get that done. But it's going to be a bit of a push because I'm being a perfectionist with everything. But anyway, let's get the big book of circuits out here. Maybe we'll calm ourselves with a little breadboarding. A little light breadboarding instead of having people yell at me about locks. This is my desk. It currently doesn't have a giant book of circuits on it, but we can remedy that using one giant book of circuits. There it is. The big book. Hailing from 1974, this book is filled with little example circuits. Now, the cool part about that is that we know how to build circuits, and nothing in here is going to be all that technological. The worst that we found is a circuit that uses a vacuum tube switch that is able to switch thousands and tens of thousands of volts in an instant. And it uses a little bit of a radioactive thing in order to make it pop off a little cleaner. And it also happens to be a primary component in nuclear bombs. Is that? Oh no, the overlay's over here. But we are not making nuclear bombs. We're not making a nuclear bomb. We're making multiples. Yeah, so we're not making a nuclear bomb. But we don't have access to that kind of thing, and eBay is only as good as it gets. I don't know. Maybe I could go around some of the New Jersey flea markets, and maybe I'd happen to find, like, oh yeah, this is a component used to build a nuclear bomb. I'm glad you asked. Like, So anyway, I got to go answer some questions at my local police station. Wonder if modern nuclear bombs still use that mechanism. I have absolutely no idea, and if I knew, I couldn't tell you. This hails from... Where does this book hail from? Where's the date on this thing? Here's a Dewey Decimal number. We got... Right here. This is the page. What? It was set in Spartan Heavy by the Fuller. That sounds like a Halo thing. Printed and bound by Kingsport in New York, which is no longer around. They're not around to sue me for showing their book on stream. Where's that date, though? Well, the Dewey Decimal says 74 up top, up here. It says 74, so it's 1974. But, I don't know. There's a date somewhere in here, and it's 1974. Legalize nuclear bombs. Bees make honey. Guidebook, John Marcus, New York, St. Louis, Johannesburg Press. Blah, blah, blah. Where did that date go? There was a year in here somewhere. Oh, there's so much schmutz right there. Oh, yeah, copyright 1974. Duh. It says right here. Copyright 1974. So this is our 1974 circuits book. We know the contents. We know that it consists of little magical runes that tell us how to build stuff in order to perform varying tasks. They're organized by task, sort of category. The book is almost as old as my parents. We're all getting old. None of us are getting young. Yeah, so this just contains a multitude of different circuits, and some of them are complete and some of them are not. We're hoping to find one that is marginally complete enough that we can at least build something that does something. That something that I'm trying to does is oscillating. I want to build something with simple circuit components that oscillates, because we failed. We've failed at so many of these different circuits. We have not been able to make something that just simply oscillates or does anything. So let's find a circuit. Let's just look up oscillate. I'm getting so frustrated with this fucking breadboard piece of shit category content. Nicey little smile at the camera, look good, everybody's happy. I'm fucked. Let's find a circuit. All right, so we're looking up oscillate. These aren't the contents. We're the contents. Contents. OLMNO. Oscillator circuits, page 590. Actually, there's 2 chapters of it. So page 591. 591. Got a puppy semi watching the stream next to me. All right, 591, 591, 543. Why is this censored? Noise circuits. Actually, that one could be fun. We just make noise. Then you never know if I screwed it up or not. It's just noise. 591. 575, 577, 603. We've overshot. 598. These are looking mighty complicated all of a sudden. 592, 591. Oscillator circuits as fuck. Man, we are oscillator circuits AF all up in this. All right, let's take a look at what we have here. So, phase shift. Junction FET in 4-mesh phase shift oscillator permits varying frequency several hertz above or below 10 with a 2.5 mega ohm pot. Attenuation of feedback network in 18. Some application of field effect. No. Whatever the fuck this thing is doing, no. I'm not, no. 1 kilohertz Wien bridge. Modification of basic bridge uses larger resistor values, simplifying generation of pure sine wave for the laboratory. Audio work. Okay, this one looks pretty relevant to us. A thermistor. What the heck? Oh, this is similar to those temperature compensating N5558, but it's an operational amplifier. Can we use a TL074 and maybe just approximate this to 12 volts? The RC isn't even given. It just says RC. Just like my VCOs. Yeah, the ones that I've not been able to get working to this date. But I did have to buy a specialty thermistor for $20 from an audio company. We haven't been able to get anything working in this lab in a little while, and I'm trying to look up something that'll actually be able to make me do something, get something working, anything working, so that I can get my confidence back, because it's completely fucking shot as of lately. So we're looking up the oscillator circuits as fuck, and we're trying to get one together that'll actually do so. Oh my god, these are too complicated. I just want to get something that freaking oscillates a little bit. So I'm thinking maybe I want to try one of these sine wave makers that use something like 2 op amps. This looks like a pretty promising one. It's just that we don't have values for a lot of stuff. We need one that's actually documented properly, and that's hard to, apparently hard for these stupid these places that publish circuits. They publish these like hardly complete circuits, it seems. Here's a Wien bridge that uses transistors. FET to reduce, what is this? Uses a FET to reduce damping on bridge and permit use of 500K twin pot for frequency control. I don't have a 500K twin pot. I've got like 10 kilo ohm ones. Twin T op amp, 1 hertz sine wave. This one looks pretty simple, actually. I don't know what we're doing here, though. We got a sine and a cosine output from a thingy-majig that's oscillating. Pins, well, it's LM108. What is an LM108, and why does it have that? I know, it's all multi-vibrators. Tried to get a multi-vibrator once, and it just made sine waves. Wasn't nearly as fun as I had hoped it would be. Here's another thermistor. These are all just wine bridges, aren't they? Well, let's try to build the first one we found. Why not? Let's do it. Well, or this one. Either of these will be fine. Basically, the principle is the same. The circuit is built just about the same way. What are we doing here? So we start with an RC constant, and so that's creating like a cut, and then we're putting that through our... Okay, all right. Well, we'll build this, and we'll just see what happens. It looks like this is a 5-volt one, too. Plus 5 volts. Okay, so we can probably use a 5-volt compatible, like the MCP 6002. An MCP 6002 will go up to 5 volts, so 5 volts, the thing over here. Quit your whining. I'm bridging! Okay, let's get the solderless breadboard out. Probably the small one would be good, because then we can show everything that's going on, and I can build this thing, and then I can finally be cool and popular, and everybody will like me. Girls will finally call me back. Ooh, I heard you built an oscillator. Yeah, you're right, I did. Puts on sunglasses. Okay, where's my breadboard? That's the first obstacle that we're facing, is the fact that my breadboard is walked to parts unknown. We're gonna need resistors for sure. Headers, not so much. Washers, not even a little. And, oh, there it is. It's right here. It's got all our crap on it from the last time we tried to build a circuit like this. All right, so all this stuff jettison. All this stuff goes into the derelict electronics pile. Except for the potentiometers that I don't know if we'll use in the... I don't think we're actually going to use the potentiometers in the circuit, so those go too. Everything goes, everything off the breadboard, put it all in a big pile. And then we get started. Now we're going to do 0 to 5 volts on this one, just because we're going to use an MCP 6004 op amp. And it's a 1 kilohertz frequency, so it should be totally within the capabilities of the op amp, the frequencies that are available to the op amp. Yesterday we had a hell of a time with transistors, and shouldn't have. We tried to find equivalents for certain transistors that were used in that VCO, and I don't know. I got to learn something about transistors. I got to look them up, because I don't know what I'm looking for in some of the specs. You know, what can I substitute in here without having to go through all the equations? All right, so we're going to start out for the circuit. 5 volts. Oh, and we need the chip. I need the chip, which is I've set up a nice big drawer full of wonderful circuity stuff for this sort of thing. So, sorry, I'm trying to kill time while I find the drawer without you guys noticing that I'm trying to kill time. It's like what they do on Car Talk. You can tell when they're Googling it in the background, and they have to open up like the VW Vortex website and find out exactly why a VW would make a certain type of chugging noise. And they do that by telling a little anecdote or a little story, while the interns or they just feverishly go through and try to find the answer, because they don't actually know it. You know, you can only know so much, and it's always fun to figure out when they're doing that, when they're trying to find an external to their own knowledge piece of information. This is not the right one. This is all the audio plugs and switches. I've used a relay to build an oscillator and used it in boost circuits, and it was noisy. The reason that, using a relay to oscillate is not a great idea. Relays only have so many cycles in them, much less than solid-state electronics. The way that you typically would boost something is you would put voltage into a coil, and when you put voltage into a coil, it builds up a magnetic field. And once that magnetic field is established, it is sitting there in free space waiting for something to change. And when you cut off that voltage to your coil, it will then dissipate and be gone. And when it dissipates, that is a changing magnetic field in the presence of a coil. And when you have a changing magnetic field in the presence of a coil, it creates voltage. And what it'll do is it'll take that lower voltage that you've used to charge up the magnetic field, and it suddenly makes a very strong pop of negative voltage. So it'll go boom and shoot like a huge chunk of negative voltage in the opposite direction because of the right-hand rule, you know, the electrical engineering gang signs, you know, Lorentz force, man. Anyway, the coil will produce a high voltage spike, and if you smooth that spike out with capacitors to store the energy a little bit, to delay it a little bit, to build it up after a whole bunch of pulse cycles, then you can actually create a step-up voltage regulator that is very efficient. EE stuff is a whole bunch of little tricky tricks like that. 9 volts to about 700 to 750. Why would you use you wouldn't want to use a relay in that, because you don't want the mechanical parts. All you want is that coil and a magnetic field. So you just use a coil, which is what they do in those regulators. We need an MCP 6002, which is a 3 to 5 volt op amp. That could potentially work at audio frequencies, I think. You have gotten a blurry. Congratulations. So that's TL072. One of these bins has the right thing. I swear. I'm not lying to you. Actually, these are the ones. These are they. Are these they? MCP 6002. The 2 being how many op amps are in this thing. So this is the chip that we will be using. CVS drivers mostly used nowadays for hobby high voltage. Hobby voltage. I don't do stuff with high voltage. I saw Uo was messing around with a Tesla coil. I can't do that because the computers that I wear keep me alive. I don't want to blow up an insulin pump just because I got hit with a spark. The last one that I made was that type of bridge that it's like a diode capacitor bridge that you can use to make extremely high voltage DC. There was a catalog that I bought the plans out of that put it in a piece of PVC and had it made it into a little gun. And all I was able to do is, while watching TV, I can make it glitch out a little bit. It didn't really work. Then it gave me diabetes. No fun Tesla projects. We did have a Tesla coil in here at one point. We did have a Tesla coil because it came with the Creality CR10S that I bought. I got like a $1 deal on a miniature Tesla coil. And so we built the miniature Tesla coil, we put audio through it, and it went bzzz, and then it stopped working, and my lights stopped working. So, seems like playing with fire, except being burned, your heart just stops. I'm not on a pacemaker. I have an insulin pump. But yeah, messing around with like super duper high voltage, not great around microelectronics. Let's say that. All right, so we have 2 different circuits here that do the same thing with 2 op amps. This one appears to not be temperature compensated. This one appears to be temperature compensated, but it doesn't give you any of the values of the stuff. I don't see there are no numbers on these things in order to get the various stuff. So I'm thinking the one that has all the numbers on it is probably the one that I want to use, but I'm going to have to look up this specific, well, 1 and 8, that's just a decoupling capacitor. Never mind. There's a decoupling capacitor on the 2 op amps. And then is this one using 5 volts or is it using 5,000 volts? What are we doing here? It does not say. 6.3 volt Zeners. Frequency output is equal to 1 hertz. 2 op amps with A1 connected to 2-pole low-pass active filter and A2 integer Zener clamps, or Zener clamping. We've got a capacitor. We've got resistors. How is that sine wave output? Where's the sine wave coming from? Stabilize output amplitude. Circuit virtually eliminates even order harmonics. Just what I was hoping for. 50 dp at output of 8.2. Do we need the clamp though? I'm going to look up the LM108. LM108 data chart. Should probably clean up some of these windows too. Analog devices, LM108, which is precision operational amplifiers, partially well certified, FET input amplifiers, bias current, LM108, do not change the temperature variations. Okay. Cool, but I don't have an LM108. I might have an LM108, but I don't know where the one is. Yes, it's an, you don't need to type op amp in the chat. You don't need to type that. I know what it is. That's what that symbol is. View, wide supply voltage, 2 volts to 18. Huh? Analog devices and what? That corporate what? Linear? Lucent Technologies? Somebody walks in the door and the phone immediately rings. What in the hell? I'm just listening to this go on upstairs. Somebody walks in the door, closes the door, and the phone rings. People like stalking where the people are. Typical applications: compensation circuit, alternate frequency compensation, feed forward. I don't care about this stuff. The typical applications for op amps, you can just look them up online. You find better circuits for that. These are. It would be funny if this circuit books was just copying these application notes. They might actually be, to be honest. Wait a second. Sample and hold. Well, that's also something used in music. Summing amplifier, bilateral circuit, differential instrumentation amplifier, sample and hold. Where's the oscillator circuit? Because they're doing something in the schematic that I see in the book that looks a lot like what they're doing in the schematic of the datasheet, which is, first of all, 30 picofarad decoupling capacitor, but it's drawn under the op amp from pins 1 to 8. And pin 1 and 8 are the supply voltages. They're not marked in any way to be a supply voltage. They don't get like an arrow here to say V plus and minus. So like, why are they exactly the same in here? I'm wondering if maybe they took circuits out of the applications. I don't see an oscillator in here. I see sample and hold, the summing amplifier. What is that one? That may be the fast summing amplifier. It just really seems like the LM108. It would be very funny if they just took, oh, that's just my hairy hand. If they just took these circuits and just built them. Or just publish them, like, look at this cool circuit you can do. It's directly out of the datasheet. The most boring thing they could have done. I don't see it in here, but it does look like it's the same style of schematic. And, you know, schematic style will differ from person to person. Yeah, they could be just basing their design off of that, but the thing is, there's a couple little signatures that I'm seeing here which aren't necessarily limited to certain, you know, styles of datasheet. But like, for instance, the variation stuff, right? You like it all. Okay, this is a teaching moment. This is a teaching moment, chat. If you wanna know a little bit about the ins and outs of the way reverse engineering goes and building a case for what's going on in the background, you can see two different styles of schematic going in here, and you can see two different styles of labeling and naming stuff. The fonts used, the size of the fonts, the thickness of the lines, the fact that they got the dot on the four-way crossway, that's probably not connected, and that is. Just these little variations, like this one is totally different from this one. It is a thinner font. It is a larger op amp. It has the things coming out of opposite ends, plus and minus, have circles on them. Whereas plus and minus aren't even labeled on this drawing. You don't know where they are, except for maybe this ground right here. Now, if we look at the way that things are laid out in this data sheet, those subtle differences can be seen in, like, there aren't, between this one and that one, there are not subtle differences. They look very, very similar. The size of the font, the size of the lines, the size of the dots, all that stuff is very similar. I don't see a temperature compensating thing on there, but that kind of T resistor, is that on the other one over here? No, this one doesn't have a T on it. It's labeled as a thermistor. But it strikes me as like, did they photocopy this out of an application note for the LM108? Let's look it up. LM108 application note. Oops. I am going to guess that we will find an oscillator. These are similar to the circuits that we saw in the data sheet, like we saw this stuff. So the question is, Are we going to find the exact circuit from the 1974 book? In here. And the answer may surprise you. We don't. This is just the data sheet again. That one shades in the amps. This is the one we looked at before. We've already seen this. We've already seen this. Yeah, if it's all the way back from 1974, somebody would have had to photocopy it into a PDF and put it up on a website for us to really nail this one down. But I'm going to guess that that's the case, just because of the style of the schematic. Anyway, let's get to building this thing. It shouldn't be that hard, but every time I say that, I'm wrong. That's funny. They're using single op amps. We're just going to use a dual op amp instead of the single op amp nonsense. Yeah, I know. But this isn't that bad. So let's start just building it, I suppose. I don't know what my voltage levels are going to be, but we've got a 6.3 volt Zener diode thing sitting on the bottom here. I'm gonna do 5 volts into this beast. But where is our oscillation even coming from? Because there's no power over here. F0 is equal to 1 hertz. Are we supposed to be putting in an F0? Is this just modulating a 1 hertz sine wave? Uses 2 op amps with A1 connected as 2-pole low-pass active filter and A2 as integrator. Zener clamps D1 and D2 stabilize output. So the Zeners are clamping. D1 and D2 are the diodes. Stabilizes output amplitude. Circuit virtually eliminates even order harmonics. It's like the little details aren't there. The stuff that I need in order to run this. Because if I power these, that goes to negative. Cosine output, sine output. Does it just start oscillating on its own? But where does it get the energy to oscillate? Certainly doesn't get it well by the comparison of these two. What kicks it off? Charging up C1 from what? There's nothing. Unless this goes positive and then it feeds back. So maybe we don't need any. All right, let's see here. Am I going to need the clamps for the MCP 6002s? Maybe not. We're going to do 5 volts. I'm going to do 5 volts on this thing. Should be possible. And then we'll see if it doesn't work. And then I get mad. Yeah, they don't represent the voltage rails. We've got a ground, and we know that these things have to be powered, and that's all we get. We don't get any other, like, where's the energy coming into the circuit? So let me perch this thing over here on top of Dave's synthesizer so I have a little bit of room to actually function here. Just like that, so it crushes everything. Okay, so let's try to get this circuit together. We have an MCP 6002. It's going to be 2 op amps inside of this package. MCP 6002. Oh, you found it as with a TI thing? Yeah, for any of you in chat that want to follow along, this is what we're building. Page. Oh, you found the full app note. Oh, yeah. Op amp beats FETs. What? Wait, huh? Is this another controversy? Please, all of the musical stars that I know are all awful people. Not know personally. Although one of them did buy a friend of mine a velour tracksuit. All right, let's see here. So page, you said 16. 11, 12, 13, 14. There's nothing like counting to build up your confidence. Sine wave oscillator. So here we have the original circuit, and this is exactly as it is in the 1974 circuits book. Referenced in the figure caption. Yeah, they do give credit where it's due. This is not like a plagiarism thing. Nobody needs to get H-bomber on the red phone about this. They're actually crediting the right thing. It's just you guys are pretty eagle-eyed, and I haven't really shown this very close up. Whatever Taylor Swift says about op amps is what I believe. All right. It's a weird one. I'm sure she loves them because she makes music. Where's my light? I have my light all the way over here. There we go. Okay, yeah. So this is all referenced and everything, so you can look that up, or you could follow the link in chat. There's a bug in here. There's a big fly. Where did it go? Oh, there it is. Oh, it's a big black fly just floating around. It's not even fast. It was like really slow fly. Okay, so here's the circuit, and we probably get much more detail about it down here. Oscillator approximates a sine wave, making one driver's high pitch, blah, 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 blah. Unique solution to most of these problems shown in Figure 19 is connected to two-pole low-pass active filter. Figure 19. That's Figure 20. Amplitude disabulation is confluence of center clamp types due to distortion, but is reduced subsequent low-pass filters of D1 and D2 have equal breakdown voltages that resulting symmetrical clipping 40 dB, blah, 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 blah. Give me more details. Where's my my voltage and stuff? Diode connected collector short base NPN transistors with emitter base breakdown of about 6.3 volt works well. Positive temperature coefficient of the diode reverse breakdown nearly cancels. Negative temperature coefficient, blah, 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 blah. LM1118 is particularly useful at low frequencies since it permits use of small capacitors. Circuit below oscillates at a hertz, but uses capacitor in the order of 0.1 oof. This makes it much easier to find temperature-stable precision capacitors. Some judgment must be used as large value resistors at low temperature, blah, 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 blah. Note, large value resistors available from Victorine Instrument, blah, 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 polyphony resistor, Whippany, New Jersey. Useful in the circuit for output frequency up to 1 kilohertz. Beyond that, either performance can blah, 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 blah. Okay, I don't know. I don't know if this will work with the chips that we want and giving it 5 volts because the 6.3 volt clamp. We won't put the clamp in and we'll see what, there's a bug. We'll see what'll happen. I got all these lights on, so the bugs are naturally going to go towards all my lights. So, building this random circuit, random test circuit. I would start with power, but we don't, like, nothing is powered on this. So let's just look up our MCP 6002 just so we know what the pinout is. That was over here. Open that up, and now we know what's what. Recommended for automotive design. What are you possibly going to be doing with that thing? Status in production, documentation. Oh, this is a 1 megahertz. Wait a minute. It goes up to. I guess it goes down below that too. MCP 6001, blah, 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 blah. 6002, here's the pinout. So VDD and VSS, plus and minus. Pin 8 is going to be 5 volts, and pin 4 is going to be ground. Man, we're back in DC. We're no longer doing these crazy AC things, although we'll probably end up doing something eventually in AC today. Nice to be in DC for once, though. So pin 8, pin 4 is ground. This one over here. Pin 4 is ground. And if you guys are unfamiliar with solderless breadboard, contained within this piece of plastic are metal clips. They're just metal clips that are one piece of metal that's been folded up. And so just like my fingers here, it has 5 little clippy things for you to insert a wire into. So if you push a wire into there, it will connect to all 5 of the positions that go vertically here, and then all of these bus positions. Some of the older ones have a split in the horizontal bus right here, just in case you have that many different bus voltages running around. I like the ones that connect it all. I understand why you would want like a variation of that, but you know, I typically set up my voltage rails in a particular way, and these are labeled. They have a red label and a blue label, and usually I do blue is ground, red is positive. In the case of this circuit, because I don't want to wire this all the way across, I will just use this rail on the one side, since we're just doing 5 volts. And so what that means is that my positive voltage needs to have a long wire going to it. So I need to find a wire that's going to be long enough to get me to this little side pin here and then all the way over to the rail. And for that, I have a jumper kit. The jumper kits are a dime a dozen, kid. You buy a jumper kit, use up all of them, they all get squiggly, you throw it out, and you buy another one. It's unfortunately very wasteful, but that's just the world we live in these days. So you buy a simple little $14 pack of 4 for these little jumper kits. Some people cut their own. I don't do that. The split makes me think my circuit isn't working sometimes. Yeah, you gotta know your hardware. It's unfortunate. The chips are passively powered. Yeah, the junction leading to pin 3 in each of the top op amps is your plus V rail. The junction leading to pin 2 is your minus V rail. Are you talking about... but it's also my sine half. But we're going to build this exactly as it is presented, and we'll see what happens here, because I think what's going to happen is the op amp, not that it's going to invert, but just the way the op amp works, I think it's going to induce some voltage on here, and then it'll react to its own induced voltage, and so the C's and the R's will then come into play with all the loops. So they'll get their way eventually. I didn't communicate that to you guys, so yeah. But it won't determine any difference between these two at first, at time equals 0, because nothing is influencing them. But then I guess that would mean that this would output something, and then that would feed back through the loop. So anyway. So I need to find a line that's going to get me over to my voltage source. Wow, this kit is actually not looking too snazzy. It's missing a lot of stuff. I mean, I could set it up so that the rails are, in fact, I put this off by 1, and now all this stuff is in an annoying spot. All right, move this down. I gotta do my grocery shopping tonight. Damn it. I have other stuff that I need to do, chat. I gotta go. Bye. That barely fits. I need something just a little longer than that. And this kit is starting to look pretty beat up. The other thing that I could do is just a small jump over to a big jump. So I can take something like this, and I can put a little kink in the end, and then take this over to here. There aren't many other places that I'm going to need positive power, though. Just take that over to there. It's a little sloppy, but it'll do. And then I can jump positive. There's like a... Where are all my jumpers? These kits are not in good shape. We'll just take a slightly longer one and just do this. Oh, that's even more clumsy. Whatever, who cares? Anyway, that powers our chip. I'm not really certain we need a decoupling capacitor. I don't know if I'm going to spring for that. But what we do need is a 0.02 UF 1% cap going to pin 2. There's our circuit. So let's get capacitors out here. I got a whole kit of these precision capacitors that I got specifically for this purpose. We also have some caps that are laying around up here. And it's possible that we have the same values sitting out. But 0.02 oof, that would be 0.0, I guess 22 NF is what we're going to shoot for here. We're going to near enough as makes no difference on these values and hope that we get anything resembling something that's oscillating. So 223, I think I've got one of those out already. Yeah, 223. So this is 0.022. And that goes from pin 2 to pin not quite 3. So from pin 2, we want to get out of there. Ah! Something just shifted over there. I mean, I can skip over, but that gets me to where I pulled in positive power. God damn it. I'm going to put power on this side. We'll just do that. We'll put plus on one side, minus on the other. It's the only way I can make it clean. So from there, we go through a 22 mega ohm resistor, 22M. Make sure this connects. 22M. We'll need the capacitors back in just a second here. 22M. I think I have 22M. Happy little jumpers. Little yumpers. 22M. Or if I should go to the horse show. Devon's doing their big horse show thing. 5M6. That's going a little beyond. What would you need that much resistance for? That's an insane amount of resistance. 10M. 4M. 3M. Here we go. 2M. Now it's asking for 22M. If we do 2, is it going to be that far off? All I care about is that this thing does anything, right? Tater, I got it, man. I got it, dude. It's okay. Don't worry about it. I got it covered. 3M3 is the other one that I have, so we'll just do a 2M. I probably actually have surface mount of that value, because I've got more surface mount than I do through hole. A lot of our breadboarding here is a little frustrating because I don't have quite the same stock of stuff. All right, now we could just measure this with our hands. We can measure this anyway. I have a special little tool for doing this stuff. It is too expensive for what it really is. You can go on Thingiverse and you can find breadboarding tools that'll do the kind of measurement that this thing does. I mean, this is something you could easily 3D print. This is something that has all kinds of little nooks and crannies that help me measure out these different components so that I can get them to the proper length. Now, what this component is doing is it's going between this area over here on the other side of the capacitors. Pin 2 over there, that's where a sine wave is. We'll do the feedback in a minute. I need this 22M to go to this pin right here, which is pin 3. So this one technically I could throw down between, well, no, it goes from the capacitor. So it goes from out here to this pin here, 1, 2, 3. And that is basically the size of the resistor. So I actually don't need to do anything. It's a cool tool, but it's unaffordable. Like severely unaffordable. I feel bad using it, you know? Because it's like, you guys can't, it's like, they sell this for like $60 or something. It's crazy. Because it's from Fluke. And I've not been able to find a cheap ripoff of it. And I'm sure there is. Yeah, it's plastic. It's just a piece of plastic. So there's our 2.2M that's coming back to there. This side of the capacitor also gets another 22M to whatever the hell's going on over here with the Zener diodes. Now, I don't know about the Zener diodes. Zener diodes are there to clamp. Oh, maybe this is Pace. Yeah, it is Pace. Sorry. I said Fluke. I meant Pace. It's got Pace written on the back. Embossed in the back. Mine's broken, though. One of the tips popped off. I know, I could start my own Pace ripoff of this tool. It's got like all kinds of stuff. Like I don't even know what's going on down here. There's all kinds of like measuring and looping stuff that you could do. It's a very useful thing, and there's probably like 10 different ripoffs of this thing. Transistor lead forming tool. Is this one for transistors down here? I thought it was just for like bending leads. Huh. Conform 1, patent number, blah, 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 3,612,112. It's about $35 to $40. For a piece of plastic, it's not worth it. There are Thingiverse similar things that exist. So R2 is 22M, and we're going to grab another 2M, because that's all I got. I could put a 200 kilo ohm resistor on it, but I just don't think that's necessary. I think our values can be sort of near enough, and it's just going to be, it's all going to come out in the wash. So 22M from this junction, and it's the only other place it goes. So I'm going to do another one where I do this, but then I'll take it to the other side of the board, because that's where it's going. It's going to the other op amp over here. We're down here right now. So we're doing this jump right here, and then the Zener diodes theoretically would go in somewhere around there. I could make a thing that does the Zener diodes, but there's 6 volt Zener diodes. I don't know what the equivalent value would be in this circuit, because we're dropping the voltage of the whole thing, which might change a lot of the dynamics of the RLC stuff that's going on. We'll just see if it works, and then if not, I can make the thing. Yeah, Pace makes it, and they have a patent on it, so I guess they get to charge $35 to $40. And then companies that have engineers building stuff in a lab would then purchase something like that. And then some shit-stained little kid would come in and steal it from their lab and then have it on his stream. 20 years later. The statute of limitations is up. Okay, so we got that one in there. Our diodes would theoretically go here, but not right now. And then we would have 50 kilo ohm resistor to the output on the other side. So 50K, let's get a 50K out here. This is almost something that I could build by soldering, but I've wanted to do a breadboard circuit and actually get it to work. I'm getting real frustrated at these stupid circuits not working, or us not being able to build them. So let's see, there's 56 and 47. 56 and 47. Well, 47 is a little bit closer, so we'll do that one. 47 kilo ohms, a little bit less than should be, but we'll just see what happens. What's the worst that could happen? So that goes to the output of the second op amp. Output of the second op amp, because I've got the data sheet open in another window, is... I got to make sure that... Yeah, there we go. Okay, so nobody's... let's see. Pin 7. 8, 7. That's right there. It's almost not the distance of a resistor. So I can either go out and then back. How many things are connecting here? Just another capacitor to pin 2, and it's another... This one is 0.1 off. 0.01 off. So that one's an easy enough one to find, unless we already have one out. 103? 103. We have a 0.1 off already out. Ah! The parts, they're just falling in my lap. Pin 7, and if we go here... Actually, it's technically supposed to go... that. So that would be the resistor going back. That one going to pin... Oh, wait, no, this one goes between 2 of the pins. So that goes between the negative feedback and... So that's pin 6 and 7 is where this goes. 6 and 7. So I got to do it diagonally like that. So there's pin 6 and 7 now. Pin 7 is not connected to the end of the 50K right here. So we'll do this one like this. I'll bend it downwards. And now we have a stand-up resistor. He's a pretty good stand-up little guy. Hey, Bovinet, how you doing? I must do this. My confidence is shot. Just going to go between here and pin 7. So I got to spread this one out a little bit more. And just knock that sucker in there like that. Okay, so that would be that resistor. This is available. The circuit is available online. If you scroll up in chat, or if you want, I can link it. Where did it go? My God, it's all locks. Everything is locks. I'll close some of these lock picking things so I actually have my windows up in front of me. Okay, so here is the page 16. Hey, what's up, first time chatter? Paste. Page 16 of, oh wait, hold on, that's a huge link. It's so stupid, hold on. The HTTP redirect, little tracking thing, and reference equals BF. Anything after the question mark should be deleted off of links. You guys should know that for just about any link. Everything after the question mark, you censor. Okay, so here is that. And that's a TI application note. This is from a giant book of 1974 circuits. It's a big compendium. It's good to use as like a reference for when you want to build a schematic of something you don't really know much about. You can look up kind of the base functionality of the thing you're trying to build, and you can look at what other people have built. It's getting inspiration from other things. It's sort of like an art book or like one of those. I knew somebody who had a program where they could, it would actually help them place all of the references for their art. It was something, it wasn't like MS Paint. It was like slightly more functional than that. I should have remembered what that program is, because I think that would be very useful when we do MS Paint style circuits. But what they could do is just take a bunch of inspirational pictures and stuff and throw it up on a big collage. And it wasn't Photoshop. It was much lighter than that. It worked really, really well. That's kind of what this is for electrical engineers. This is sort of, I need something that does a function, and I want to look at things that do a function. Oh, look at these things that do a function. This one does it this way, this one does it that way. It wasn't Paint.net. No, it was a different program entirely. I know Paint.net, I've used that before. But you look it up and you go, oh, that's how they do this circuit, and that's how they do this circuit. Maybe I could do it like this, but change that and do that. And you sort of like, you know, leapfrog off of the designs in here. So what we're doing is we're trying to build our confidence in building an oscillator, because I've been screwing this up every way to Sunday, and I'm getting a little sick of things not working around here. So we found a relatively simple op-amp circuit. I don't have exactly all the values of this thing, and we are changing it to be 5 volts, but I think, all things considered, I think we'll probably end up having something that oscillates, I hope. let's just get the components down quickly, and then we can see whether or not it blows up. Between the two, between pin something and pin something, I have a 10 mega ohm resistor. That's a big boy. That's a big resistor. These are, so big resistors, small capacitors. What's going on is we are charging and discharging capacitors with high impedances. So everything is preventing the flow of electricity from place to place, and we need to build up very small voltages and bleed them down very slowly. So we basically have like a bucket of water, and we have a very small tube feeding it, and then we have a very small tube draining it. And so in turn, it'll do stuff like that. You know, it's whatever. Anyway, the water analogy is ever present and always on my back. 10M goes between pin 1 and pin, whoa, there goes that bug again. Pin 1 and pin inverting input, pin 1 and pin 6. I'm just gonna put that straight over top of the thingy-majig. That one, wait, I need 10M? That's a big one. It's a big boy. Oh, we have a 10M right here. And there was one of them that was, yeah, here we go, 10M. Boop. Ugh, common values are nice. It's nice when they use common values. It's merciful when they use common values. So this is going to go over top of the chip, but it's not one of these temperature compensating things. Those VCOs that I have that don't work use that. Pin 1 and pin 6. 1 and 6. 876. That's all the way down here towards the 4, pin 5. What is pin 5 doing on this one? It goes to ground. So actually I'm going to need that. This is going to get even more awkward as I don't have the means by which to flip. I should have flipped the chip around, to be honest. I'll use this. I'll do this in a very janky way, because I think this is the last component to go in. All right, so there's our circuit. It's a little bit too compact for my tastes. I probably should have spread this out a little bit, but I was just kind of working within my means. So if we give this 5 volts, we should see oscillations on the outset. I am going to plug in my scope now. I have a big fancy scope that I bought specifically so that I could put it up on screen. I don't actually even have to move it out of this location too, because it'll show up on screen for you guys. Now look at how quickly this scope boots. This is why we paid $700 for a scope. This is a very expensive, for me, scope. Not expensive for other people, but look at how quickly this scope boots up. From when I press that power button, we will see that this thing actually gets to the part where you get to use the scope in a lot less time than you would think that it would take a $700 scope for you. Because back in the day, you had to wait for like tubes to heat up and stuff, and that took a little while. That took like 10 seconds or so. And you know, the CRT would have to, like, the electron beam would come in. But you can see that after I've hit the power button, this scope is going to get online very quickly for a digital modern scope that doesn't really need to do much except maybe load something from static memory. It gets right up in there and it functions very, very quickly. There it is. You get that? That was amazing. It takes like 58 seconds for this fucking scope to power up, and I don't know why. Why does it take so long? You're not doing anything. It's ridiculous. But anyway, the advantage of the scope is that I can put it up on screen. Oop. Yay, scope. 12 years later. Yeah, exactly. I've been soldering loads of 0402 sized with 2020 RGB. Yeah, 0402 will make you, it'll really make you feel like just breaking something. You just want to break something over your knee and yell into the void, because everything looks like it should be totally solderable at that size, because when you look at it on a microscope, it's like CAD drawings. You don't understand. You don't get the sense of scale. And the 0402, you don't get the sense of scale, and then you try to solder stuff with it, and nothing lines up properly because you're humongous in the face of such tiny electronics. 0603 is really the size where you should be looking. when the void yells back, when your cat goes meow. Meow, said the void. All right, so we need 5 volts. So I'm going to use my custom power supply for that, which means these awful easy hook clips that pop off very easily. This is just a little custom jobby that I have. I had to bring back the Agilent specifically for modular synthesizer stuff, because this has positive and negative. Which, if I had more than one of these, I could also do positive and negative, but Pup just did a big stretch. Puppies are cute, especially when they're hanging out. Mine's upstairs, looking for stuff to bark at the door. She's probably napping, actually, but... all right, so we're set on 3 volts. We go up to 5. We're going to do 5 volts. The MCP 6002 can stand up to 6 volts. We're going to do 5. We don't have the clamping diodes on the output. Now, hooking up the scope, I have this on... Actually, I have it on... It seems to be on a DC mode, but it also recognizes the validity of this... let's see, where are my leads? I use the little plug-in leads for this stuff. Actually, I probably have leads just sitting around. Yeah, here. Let's grab some of these. These for power and ground. And we'll make blue and white our grounds. So that's the ground over here. This one's a power. Power supply is currently off, but it is set to 5 volts, because this one you can actually set while it's off, which is rare. And then this one is ground. Goes to ground. Nice clean setup. It's not really that clean though. My circuit building could be a little neater. If I spread out, it probably would have been a little better. But okay, and then this is where we're going to sense whatever we're sensing. And so we're going to look at, let's first look at the cosine output. The cosine output is the junction between the 0.1 UF cap and the resistor that goes to the other side of the board. Is every pin used on this thing? It is, okay. So that would be the output from this. So this is this one right here that we should be able to see a sine. Why is there already a wave? Something, when I touch it like this, and you hold me like that, something about the circuit's RC, like, properties are transmitting some kind of a square wave, probably from my lighting. Yeah, it's probably 60 hertz lighting noise, but usually you get like a wave like this. There's my LED lighting causing a weird pseudo kind of positive negative. Who is this doing this symphatic type alpha beta psychedelic funkin'? But then when you connect it to the rest of the circuit, it seems to be clamping it into a waveform, which is kind of cool. Who is this doing this symphatic type alpha beta psychedelic funkin'? I'm cleaning up a little bit. I don't like to have a lot of clutter when we do a test setup. Let's check out what happens when we put 5 volts into it though. So 5 volts. Go. Good. Good. Fucking nothing, of course. Nothing happens. Of course nothing happens. Yeah, that's what I wanted. Beautiful. Well, at least we don't get that noise. Are we seeing like millivolt things happening? No, we're not. Cool. Very cool. Very cool. Let's first of all turn off all the channels we're not using. So we're on channel 1. And we got it on pretty sensitive. There's 1.5 volts up there. So any noise that comes in from myself or from external should be pretty well documented. Now the question is, did I put the chip in the right? Something's happening when I push down on it there. We got a lot of weirdness from the elements that I'm using, from the components that I'm using. But I don't see anything that the clamping would do. Move in the grounds. Ooh, without the grounds you get all that noise. It's referencing on basically an antenna, so. No movement from any of the circuit elements. Let's take a look at the sine output, and that's on the output of the other op amp, which is pin 1. And you know, the question is, did I hook everything up correctly? Whoa! Well, that's a result. Let's get a trigger on that so that we can characterize this a little better. and then de-widen it. We get the beginnings of a very slow waveform. Oh yeah, and see, as I wiggle the elements, certain things are connecting and disconnecting, and so we get varying performance. It's these resistors, man. I gotta find a normal type of resistor. I have to find a normal resistor because these aren't making good contact. Look at what it's all over the place. All I gotta do is poke a resistor and suddenly everything comes into focus. Yeah, see, that one's supposed to be limiting that there. A hideous scope UI. Why? What do you prefer? Dear God. Ugh. The best part about it is I'm seeing exactly what you're seeing. So I'm viewing this with the same frame rate that you are. It's being transmitted onto my intranet, and then OBS is opening it up as a web page. And it's a touchscreen interface. Yeah, it's like each circuit element is not quite connecting properly. And so if I jiggle it a little bit, it's not only injecting my noise, but it's also making the connections that should be there. And then all of the equations are doing their things. Let's see what the other one looks like when I poke it. Oh, no, I lost the resistor. A resistor. I don't know where that one went. Where did it go? That one was between... Let's see, which pins were it? Is that one and... Well, pin 3 is the feedback, and that should be the junction between... Yeah, there's something... Something's a little wrong. Oh, I forgot a jumper. That's why. I forgot to jump pin 2 to that. Okay, so pin 2 is supposed to go over here. Let me power it off, and I'll check over my circuit again. The gradients on the buttons make it look like it's from 2000. Well, maybe that's when they made the UI. It's, I mean, the functionality of the scope puts it into that price range, not the UI. It's okay. I don't mind it. It could be, you know, a little bit more simplistic and flat. But that's just the style at the time, you know, that put an onion on your belt. So pin 3 is the plus sign, and this would be the 22M that then goes all the way around to there. So I need, oh, and I forgot a capacitor to ground too. Yeah, we're missing a bunch of stuff. We're missing like an entire RC element out of this thing. So let me double check what I have. Let me disconnect all this stuff so I can see. And here, I'll bring you guys in close. These wires out of the way. Okay, so here we have the 2.2, and that goes from, so pin 1 on this side of the dual is out. So output here, and I guess I can move this like this, and we can focus that in. There is our circuit, and one of the most fascinating thermal images you'll ever see. There we go. Okay, so we have a resistor fell off, so now I need to find where it goes. So pin 1 is the output here. Pin 2 is the inverting feedback here that needs to go to pin 1. So I need to put a jumper right here. So let me get a little jumper, a jumper, and then we put the jumper right here, and that connects the two. So now those two are connected in a unity gain feedback loop. Look at how hot my tweezers are. Those are some hot tweezers. I need to figure out what the lens is going to be to make a thermal microscope, because I've got the camera module that we could turn into a thermal microscope. It'd be nice if I could co-witness this view with a really small thermal view, because we could see the micro thermal reactions going on. I think that'd be really cool. Anyway, the point is, I haven't put this 0.1 in here, I don't think. 0.1 to ground. No, it's not in there yet. So it's a 0.1 microfarad to ground on pin 3 of the op amp. So let's get a 0.1 oof. I thought I was done. But they brought me back. Brought me back into the game. That's this here. Why isn't it closing? Okay, closed. Put that away. Put that to the side. All right. So 0.1 is going from pin 3 to ground, which could be across here or more to the size of the actual device. I could just put it in like that. I'm going to cut that a little shorter though. Macro lens to a thermal camera, attaching a thermal camera to a C-mount microscope. Neither. I've got a thermal webcam, the second of the unit that I'm using right now, and it is a type of pinhole camera. So it does actually, if I got it close to the stuff, I could get it to do good microscope image, but it would get in the way of my long standoff C-mount. So if there was some kind of a lens that I could put in there, the problem is those lenses are very expensive. Thermal lenses are extremely expensive. So I don't know what kind of lens I could get that would allow me to have the same super duper tall standoff and have an image that's about the size of what I'm looking at right now. It being in focus, it probably would be in focus just by virtue of the fact that it eventually goes through a pinhole style lens. Pinhole lenses are really good. Called a Barlow lens. Right now, the reason that we have microscope is because I have a it's a C-mount camera holder, but it offsets the actual image plate by quite a bit. Now, which resistor was this one? This looks like the 2.2, and I think it's this one here, because the 10M is right here going between the two. And then we've got one that goes down and to the second part of the circuit, which would be, well, we've got a capacitor here. That's this one. So, okay, this capacitor is this one. Then, oh, I see. Then we have a 2M that goes to the junction between capacitor and the other 2M. Okay, yeah, that's where this one goes. And that capacitor not being there to ground means that it didn't have an opportunity to discharge to ground. Well, it didn't have the engine, the entire thing that would run it. And so instead, this thing would discharge it. Not necessarily, I mean, those are 6.3 clamps. And this is like an overall feedback. I think we have seen circuits like this. I just didn't know, because the rearranging, putting this down like this instead of having it be like a feedback element up top, I don't know what they're thinking when they make some of these schematics. They need to go back to school and look at a few circuits so that they can make their circuits look like those circuits, because that's the best way to communicate functionality. What is going on here? Why are we double using this hole? What's going on? Okay, this one is a 0.1, and it is supposed to go between what? The feedback. It's supposed to go between output and the negative. So that would be pins 7 and 6. So, oh, damn it. Come on, man. This thing just, I keep ripping up elements of the circuit by just moving a little bit wrong. This would be the Zener diode area, and then this is the 50M. It's a little bit off from that, but that's the 50M right there. And so I'm putting this capacitor in, and I have this big chungus right here, this big chonkadoodle that needs to go in. So I could either do it by trying to tilt the capacitor, or I could tilt chat. And I'm going to choose to tilt, get you guys all tilted. So what I'll do is I'll actually put it like this, and then I'll jump back over to the one next to it. Too wide again, too wide. This thing's got like that wrestler stance. They like make themselves all wide because they've been lifting weights and stuff. Let's do that. And then we can go from this pin to this outer pin that's not used, and then I'll jump from here to here using this. No, using a different one. Using a shorter one. Perhaps I've misjudged you, Jumper. You and I aren't that different. Yes, we are. I need a longer one. A longer one. Let's see what we got. Let's see. Hip, 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 hip. Hip, hip, hip. Hip, hip, hip. Too long. Wait, is the Barlow lens isn't the one that... No, that's a different one. That's a Schlierenen imager that I was thinking of. Now, I wanted to make a Schlierenen imager out of one of those hologram toys. Because I think that hologram toy has precisely the length, or it has the concave lens. And all of the creators, all the YouTube creators have been making Schlierenen imagers, have been using professional optics lenses. I think you could get away with the Discovery Channel store toy, the one that makes that little, it's that little concave hologram toy. It's like $10. And I have one sitting over there in the wings, and I've been wanting to mess around with Schlierenen imaging. Schlierenen imaging. Okay, talking for 5 hours is difficult, and I've only been at it for 2. But anyway, this circuit should now function the way that it needs to. And I think maybe we weren't seeing a lot of oscillation because we were missing one of the primary capacitors right here. This thing was not doing nothing. So let's hook this thing back up. Barlow lens is used in microscopes to be able to have your microscope further away from the workplace. Yeah, okay, so yeah, Barlow would be the right fit. But the problem is thermal imaging lenses are so expensive. I mean, looking at Edmund Optics doesn't tell you much because Edmund expects government agencies to be buying from them, so everything is super duper expensive. But to get this 2-foot standoff that I have, I would love. I probably just smudged that. I gotta clean that now. I would love to have the microscope up here and viewing all the way down here thermally. So it'd be nice if it was a cheap lens, but I don't think it's going to happen. Or one lens. I don't know if one lens is going to do the job. Jermaine? Jermaine? Hey, Jermaine. I can't do New Zealand accents. Hey, Jermaine. No. Nope, I got to watch Flight of the Conchords again now. Positive und negative. Und ground. And then our signal, which I think we're getting from here. Whoa, noisy, noisy. But power isn't on yet, so let me turn on power. Haha, nothing. I think it's like aluminum or something. The types of lenses you need. Huh. Okay. Nothing going on there. Maybe try this output. Oh, that's not actually the output. We need... Oh, no, this is the output. This is the right one. Where it feeds back, but it's not doing anything. Okay, there's something wrong. There's something wrong with my setup. I think it's down to the clips, I think I need to jettison these resistors. These precision resistors, I think, are hurting me. They're doing damage. They're doing psychic damage to me. God, that thing also doesn't unplug. Hold on, let me flip this one around. Oh, well, also, this is not correct. That on ground. This on our output. And then it unplugs the other side when it does that. Sloppy, sloppy circuits. Yeah, it feels like stuff isn't connecting properly. It should just be oscillating. That's all it should be doing. It should just make a nice little oscillation. You get a 1 kilohertz or something. Ooh, I feel like I got a... No, that was just the metal poking me. I thought I was getting a little tiny shock from that. That was weird. Shouldn't be able to get that kind of shock here. So, what is happening here? Why is this not working? You know, it's like, this is all we do. We make circuits. And then I try to make a circuit, and everything goes all crazy on us. The only way I get it to oscillate is if I inject a noisy oscillation of my own desk. This is what I'm talking about, Chad, with these circuits not working. I don't think it's a matter of the values of the components either. I know we're off by a couple hundred kiloohms on some of them, but the result of that would probably be an out of spec sine wave instead of just nothing like we're getting right now. And then the other output is on the pin 7, so 8, 7. It's this one right here. We should be seeing something. And I don't think it's the frequency either, because the MCP 6004 operates in audio spec, unless this is our wave. Holy shit. I mean, that is pretty stable, but if I poke this thing in just the right way, it's going to go away. Everything seems very loose in the plastic. Yeah, see that? And it just suddenly stops. All right, let's find a different circuit, because that one is cursed, and I'm not going to work with it anymore. It's got all this clamping stabilization stuff with Zener diodes, and it's using a chip that's in a different voltage. We saw a similar one with the voltages that we can use, like 5 volts, and it looked just about the same. What are some of the differences between these two? 820 ohms to ground, 1K in between the two. It's got a thermistor on the feedback of the second amplifier. It's this one over here. Circuit fussier than my cat. I think it's down to those resistors. The leads on those resistors are very thin, and so they cause a lot of problems. So this one has an RC on this feedback. 47 pico and 330K. This is operating... It's got an RC here that's completely unidentified, which is why I didn't choose it. Negative 15, so this would be a TL072 circuit if I really wanted to. Minus 15, and I'm guessing, yeah, no, plus 5? What the heck? Minus 15 plus 5, and then a 0.1 up to ground on that minus... Holy, what the heck is going on with that one? Did they forget a 1 in front of the 5 on that one? Let's find a different oscillator entirely. Let's build something completely different. Let's get this thing out of here and forget we ever did it. Because for some reason, lately, my stream has just been a series of failures over and over and over again of me just failing to do the most basic sort of electronic premise. And the whole point of today was to try to find a circuit that I could put together and have work. So we started the chapter with these Weinbridge oscillators, and apparently that's just cursed. Yeah, 5 and negative 15. I don't know what that negative 15 is doing there, or if it should be plus minus 5, or it should be plus minus 15, which makes a little bit more sense for the kinds of stuff that's being done here. Unless they want to take your generic power supply and they want to output something that'll work on like a speaker, and so they're using... Come on, focus, camera. Oh, that was hitting the wrong thing. Okay, so let's see. There's a couple criteria here because these circuits are from 1974. In 1974, you know, we didn't have as much 5-volt electronics. There was some logic gate stuff that was out in 1974. But I mean, the 7400 series, I wonder why it's called 7400. Is that because it was made in 1974? Not really sure. When did the 7400 series originate? That's a question that I should be asking an AI, and it'll tell me that I should eat pizza. 7400 series integrated circuits. In 1964. Okay, so it's 10 years off. SN 5400 series logic chips in a ceramic semiconductor package. A low-cost plastic package 7400 series was introduced in 1966. So that would be the 1966. So in the 60s, we have the 7400 series logic chips that are typically TTL, and they work on plus 5 volts to 0. 1974, we don't have as much of that though. It exists, I guess, but a lot of the electronic stuff is like plus minus 15 volts, which is like I guess was like a common audio sort of thing. And so everything is analog and everything is plus minus voltages. So we're going to look for something that's in a reasonable voltage. Hopefully it's not like coming in from the wall, and I want components that I can actually source. So if we can get some of those basic analog components and make kind of an oscillator with that, I'm hoping that'll give me a little bit, like just kind of maybe shove a little brain wedge in there a little bit so that I can start to understand how I can fix all of these audio things that are not working for me. Maybe it'll get me in the right mindset to start messing around with that. A lot of the things in here, though, are not publishing just your basic, like it's like you have a magazine, you don't want to publish like Jimmy's first oscillator. You want to publish this oscillator that has a cool take on making oscillations. My hair is, I don't think it's that good. He says, hunched over like a shrimp. All right, so what am I looking at here? Bootstrapping voltage of timing capacitor C1. What does that mean? 1% metal film resistors. These are all 2N2222s except for the 2N491, which I don't think I have. What's going on, Project Alpha? Twin op-amp RC. Not quite. 20 kilohertz wine bridge that doesn't use an op-amp. Sine wave will drive any speaker up to 40 ohms. They use some weird transistors in these things. You would think that if you were making just like a generic circuit for people to build, you would do something with like a 2N2222, right? But instead they're using 2N3565. Fuck simulating. We're building stuff in real life. What's wrong with you people? You want to do everything on the computer. You got to live in meat space a little bit. You got to smell the book, smell the circuit, put your hands on it. I don't know about this one. This one looks a little bit ridiculous. 0.047, 10K, 6.8K. These are relatively available, but it's these 2N3569s or 2N404 that I don't think I have. Those are harder to find. I don't have big, selections of transistors sitting around. I prefer things to use a nice simple 2222 or something, 3904 or one of those equivalents, right? This one's funky looking. Wine bridge with diode control. 4454. I don't know what that one is. Why would you draw it like this? Why would you draw it like this? Is this because it's supposed to resemble like a Wheatstone bridge, or is it supposed to like... That's a weird one. I guess this is the star of the show, this little sideways circuit here. Everything is a wine bridge. Every other circuit in here. Phase shift op amp, but then we've got another wine bridge. I assume that's how you say that. I don't know if I'm saying that correctly or not. I'm trying to keep focus on the book here so you guys can actually see what we're looking at. FET feedback, wine bridge op amp. This is another one, but instead this has like a little lamp in it. What's that doing in there? Controls positive feedback with negative feedback determined by bridge legs R3 and R4. Is that just going to oscillate like the light on and off? That's a weird one. Number 48 lamp or something like that. I don't know. It looks like, yeah, so... Oh, Winebridge being the amplifier that's used in oscilloscopes and like multimeters and stuff, right? So that would be like an amplification. That's why it's written like this, because it's actually the circuit is drawn like that, and it's made to amplify levels of stuff, like voltage levels and stuff. Tone pulse combination of Zener, Winebridge IC. It's every other circuit in here. Augmentations of coils. No. 5 decades. There's a lot of oscillation circuits. That's pretty much all electrical engineers do. You just make oscillations all day. That's all I do, is basically just oscillate. 5 kilohertz, constant amplitude. MPF 105 and some kind of an abomination. SL701C, plus minus 12 volts. Well, this looks like something that we might be able to put together if we can find MFP 105. What's it doing? Frequency variation is only 0.2%, 0.02% for 30% change in supply voltage. Output of Weinbridge oscillator. Damn it, it's another Weinbridge. I can't get away from it. Every single one of these things is a Weinbridge. Weinbridge oscillators fed back into the gate of the FET after rectification and filtering. Change dynamic resistance of FET so as to hold output constant. A BASAC, constant amplitude oscillator, wireless world, November of 1969. Somebody was clearly having fun in 1969, and it wasn't this guy. MPF 105, plus and minus 12 volts. That's looking pretty good. 6 and 4, we have a capacitor. So this is one of those singular op amps that has all this like stability stuff. If we get out of TLO72, well, this is an SL701, so TLO72 is not a far cry from that. And 120K, 0.015, we have the diode, OA200. Diode's a tough one. The transistor's a tough one. Uh, 0A200, and we gotta look up both of these components and just see if we can build this one. Not a variable. I thought it was a variable capacitor at first. I was like, wait a minute, I don't have those anymore. Variable blah, blah, blah. Variable capacitors are kind of neat because they're basically, you have 2 plates, and when you slide the plates over one another, you get more surface area of the plates and you get a different capacitor. So there's multiple plates behind a knob, and that's your variable cap. I used to have a lot of variable capacitors and I got rid of them, and I never should have done that. That was a bad thing. Okay, so let's look up 0A200. International diode equivalent. This is from like 1974, so okay, this looks sufficiently old. Oh my god. Does this thing actually have text? It does. That's a crazy one. This is a crazy one. Oh god. Now would it be A200 or 0A200? 0A200 is what I have. We have 0A. These are all the letters. So I got to go down to the numbers. Down we go. Down, down, down. That's B. Okay, we gotta take matters into our own hands. Ah! Take care of us. Oh, there's 1N. Okay, we're going back up from 1N. Z. 3/8. What the heck? What kind of cursed? Decimals, 1/2, 1. Where's 0? You're telling me nothing can start with a 0? It couldn't be an O. No, that's the... If it was, it would be OA200, which is definitely not what we have. Could it be, yeah, could it be after 9? Because here's Z. And then we jump into 1/4. That's like 14. All right, after 9. Ugh. I think it only goes up to 4. Yeah. What's in the title? We're looking up oscillators. There's a couple different ones, but they all seem to be based on Weinbridge circuits. And so we're just jumping around and trying a couple different ones. I mean, RS latch and gate loop oscillator. Well, that's not going to be in this book, I don't think. We're looking. The whole point is that we're doing stuff from the book. Oh, here's O's. It's not 0A, but 05. Why are they snuck in there? What are we counting in binary? What's going on here? 10, and then we go 1 0 1 0 1 2 2 2 2 0 0 0. Then we move down by the 0A. I guess I could control F it, but I mean, if these are technically in here, not bookmark. No, of course it doesn't find it. I mean, this isn't necessarily like transcribed properly either. I mean, A0200. Actually, 0A200 is the part number. (202). Here, 0A HS1011 0A200 in the European part numbers. In the Europeany. HS1011. I've never ever fucking heard of that thing before. HS1011. Straight plug-in with extended pin. Aluminum house, terminal, while round. I don't know. We're chasing things here. We could possibly just put in just like a diode and see what we get. Just like any old diode. It's plus minus 12 volts, so any old small signal diode. That's not even like close to the part number. It just took diode and looked up a diode and gave me the data sheet for a diode. But if we get the diode wrong, what are the consequences? Frequency variation is only 0.02 from 30% charges. The output Weinbridge oscillators fed back into gate of FET after rectification and filtering. The change dynamic resistance of FET as to hold the output constant. What are you? And then 0.2K down, and then this one up. Well, MFP 105 would be the other one. I mean, it could just be a diode, just any old diode, but I don't know. 0A00. 1974 circuits. A lot has been lost to time. MFP 105. Let me look up MFP 105, and then I'll give up on this one and try to find a different one. MFP 105. Data sheet. It's probably just like a 2N2222. That's not the diode. Yeah, of course we can't find any of this stuff. All right, let's find a different circuit then. No use sweating it when I've got 2 whole chapters of oscillators that I can draw from. Everything seems to be a Weinbridge of some kind, but we're trying to find something that I can build here without tearing all of my hair out, because I've been getting very frustrated at my inability to actually do stuff with electronics. There have been some snarky chatters. There's been some, I just need to basically get through building something and have it be successful for once. But part of Betelgeuse fuzz diode, what? But part of the whole thing is that I've got this guidebook of electronic circuits from 1974, and I want to use it. I want to get to know it a little bit better. And so on Fridays, we're taking this big old fucking book out. I'm throwing it up on the desk, and we're finding circuits that we can build. That's part of it. It's not just that I want to build an oscillator. Pedal PCB. Uh-oh, what's this? The build docs on the Betelgeuse fuzz call for an OA200. Oh, look at that. On D1, D2, it says next to it next to that DO35. Am I safe to assume it's calling for a 1N4148? It's calling for an OA200. I used the 1N4148 for the prototype, less mojo, but they work fine. Okay, so it's a 1N4148. I wonder what that transistor is then. Hijacking this thread for a second, there's an additional question for the Betelgeuse. Stomp box, small, don't, blah, 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 BC548. 5478 transistors, would that be a good substitute? Bought these from eBay UK, blah, 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 blah. I also use BC547s. These are also relevant questions like, what can I sub in? General purpose silicon diode, 5 pieces, OA200. Wondering why they look different than the ones in my photo. Got a bunch of these from a seller a few years ago. Stock photo for diodes that happens to use the ones that I got. I actually kind of remember OA200s. I think I've seen those on some before. What are you talking about? What do you mean, why is the YouTube chat up if you're not reading from it? I am. Why would you make that comment out of the blue? I've already acknowledged Goza Adrian's cool to make a cell phone thing hours ago. I don't know if your other chats haven't been coming through or something, but that one came through. Snark that I get for trying to do what I do. Got a bunch of these from a seller, stock photos of diodes, blah, 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 1N4148, 1N914s, and the various BBs have done around these circuits. They're just another good all-around silicon diode. So it's just a diode. I don't know. The people who make these like stomp boxes are they're crazy people. So who knows? Who knows what they made it do? All right, so yeah, they all have insane. They're all insane. So the question is, okay, so OA200, which I swear now that I've actually seen these in foreign electronics before, but OA200 is just a generic 1N4148, which is just like a rectifying, like small 4148. Wait, that's a small signal, isn't it? I have equivalents of those. I think they're surface mount, but I do have them. And then MPF 105. We're dealing with a plus minus 12 volt circuit, which is why I wanted to do this one, because I am set up with the one power supply to do plus minus 12 volts, and then we can get a nice big clean oscillation wave, and I can say I finally did something, and I can be cool. Other names above aren't in the YouTube chat. No, they're at Twitch. That's why they have a Twitch logo next to them. Most of my viewership is from Twitch, by the way. You should come on over to Twitch. We've got cookies and stuff, and emotes and things. Yeah, the YouTube stuff I've been putting up as an archive, and I've been dual streaming to both YouTube and Twitch. But there's like 2 people on YouTube at any given point in time, and we've got actually a kind of a small crowd in here at 54. Oh, and Twisted Sister subbing for 78 months. Oh my God, Twisted Sister, thank you so much. Thank you. Sorry, I didn't see the alert. Have I missed any other alerts or stream things? Ben Gizmo gifted yesterday. Yeah, everything's from a day ago. This is the first person subscribing. I'm too small. Okay, so MPF 105, this MF over here. MPF 105, and I'm coming up with nothing. We thought that the internet would be forever, and that the things that we see on the internet would always be there, and that just has not been true. Things go away, and so we're dealing with that a little bit here. I got a job again, have some gift subs. Oh no, what are you doing? That's 5 gift subs. AV Fusion, Iger Zoom, that's a cool name. Krakel, Dog Vomit, I remember Dog Vomit _ and Papa Tom Carpe Diem. Hey, you guys all got Twisted Sister to thank for the subs. Thank you so much for the 5 gifted subs. That's huge. Huge these days. Y'all got subs. How's that looking? Nice. Hey, I appreciate that. Oh, that's my looking on the floor for something camera. Let's go to all of these views are terrible. This one. That's the one I was looking for. Jeez. All right. Hey, thank you for the gift subs. Microwave power transistors. MRF. Well, we're not looking for the MRF. We're looking for MPF. MFP? Wait, did I get that wrong? MPF. I got that wrong. Let's see if this fixes it. MPF. 105. Hold on, I gotta scratch near the mic. All right, you guys don't get to hear that. MPF 105, there we go. You know, it helps when you type the right number for the thing you're looking for. It's just a FET. It's just a FET. It's a general purpose FET. It's just a FET. Stop saying FET. So what can we substitute in for an MFP 105? Something that can take 12 volts, right? Probably going to be like, what's a generic FET? What's one that I would have on me? Antique radio forums. There we go. Can someone tell me the Q1 MPF 105 transistor is still available for this radio? I believe the equivalent is 2N5459 N-channel JFET. All right, to the FET book. Yeah, most of the things are going to be super, like, brick stable, super simple, old. The question is, do I have something in through-hole flavor that'll go down onto this board nice and easy? Germanium. Yeah, I think I've got equivalents of all this stuff. The 4148 I'm not totally sure about. And then these are BCs. I don't think I'm going to find what I'm looking for in here, but this would be, what are we looking for? We're looking for a, take a big swig of water. (2N5459). I mean, would a 3904? That's not a FET. Somehow I don't have it. Why does this always happen? I have all these things. I really need to label these with a bit more detail so I don't get caught up on this all the time. So I know which ones are like JFETs and I know which ones are... Because I don't know, I just bought this kit. Supposedly this has a bunch of stuff, but it's like... I don't know, what do I have? BC549? What is BC549? That's not going to be a JFET, is it? BC549. Gathering parts is one of the more frustrating things. BC549, switching, high voltage, low noise, NPN, silicon. It's not a JFET though, so it might not be switching as quickly. It's just a transistor. What do I have in my repertoire? 2N5459, don't have a manual, blah, blah, blah. 2N5459, the sheet pinout is blah. Just for the pinout, can't find the MPF 105. 102 should work. Okay. Vintage radio forums is always fun to try to find equivalents on. Oh, here's it in the other direction. What's suitable for the 2N5459? And somebody probably said the MPF. Yeah, here it is. MPF 105. 4222 2N5459. That's the one that, wait, that's the same one that we're looking up. This list is TO18, TO72, TO92. 5458, 5459, MPF 103, 104, 108, MPF 109, MFP, or PN42, PN422222. Shame 2N22222 isn't on here. Better ultra. Yeah, it's like the edge cases is where these differ, where you get to the high and the low frequencies and what this thing can possibly perform, where we're not getting anywhere near that. Not ChatGPT again. I would rather look it up because with electronics and stuff, I don't really trust GPT to come out with the right answer. I would rather sit here and sift through forums and get the good answers because I've seen too many examples of it not getting it right, and we don't necessarily know enough to tell when it's wrong. So pinouts may be the same. MPF 1, I don't care about same pinouts. Yeah, the 5458 and the 5459, I don't think I have those kinds of parts. I don't know if I have those. MMBF 57 on 70 show. Can't source blah blah blah. May do too the circuit. Blah. Yeah, I don't know. We'll see. We get through a lot of really weird stuff when we search this kind of stuff, which is kind of fun, We also are kind of sifting through the broken pieces of the dead parts of the internet. Just give me the damn cookie. I don't know. Why am I clicking so much? Why does my body need so much insulin these days? Okay, we're actually my glucose level did not go all that high from eating lunch, so it's just I get sensitive to hearing my elbow where I've got the insulin pump right here clicking, signifying that it's giving me more and more insulin. All right, let's find a different circuit because we got kind of sidetracked on this a little bit. This one would probably go together all right with like a TL072, a 1N4148, but then I don't know what transistor to put here, and we constantly get hamstrung by that, figuring out what transistor to put where. I'm going to try to find something different. I mean, op amps and transistors and stuff, those are fun to use. It'd be nice if we could find stuff that was a little bit more generic. Seeing as this is 1974, they certainly was the heyday of the 2N2222. See, like here's a much simpler one. Sine wave Wine Bridge uses current differencing single supply op amp. So single supply op amp. So we're using positive voltage only, and we're going to get, sorry if I amped you up. I've had people suggest me use AI for fucking everything lately. So yeah, I'm going to clap back when people tell me to use AI to pick my goddamn butt. I don't need to pick my butt with AI. I can pick my butt on my own. And I do. 500 ohm resistor, variable resistor. I'm going to see if I have that or not. Like, I know the allure of having AI answer all your worldly questions, but no, I'm not picking my nose with AI, not after the accident. Let's see. I've got all of those over here. I've got 100K. I guess we'll put 100K in there. What does it ask for? 500 ohms? Yeah. Well, 500 ohms, we could just use the 10K and it'll just be very fiddly. So yeah, we'll use the 10Ks that I've already got over here. This thing's asking for a 500. I think it's 500. I need one of those book stands. Isn't it like an encyclopedia stand? 500, 220, 510. This is just such a simple circuit that I think we should be able to put this together easily. Plus VCC is down. Why is it down like that? That's a weird way to draw it. And then ground. So our VCC is going to be 5 volts, and we're going to use this MPC 6002. Perfect. Let's do this one. And hopefully we can then actually get a circuit that actually oscillates. I really hope. Otherwise, maybe it's time for me to evaluate all these components. I need to search around and find resistors that are thick. These quarter watt, these cheapo through-hole resistors are costing me my ability to build circuits. I might not have the right questions, but AI has so far provided me with exactly 0 useful output so far. Same, except I haven't used it as much. I've tried using it for some stuff. Like, we tried to have it help us program things. Gonad actually got it to run quite easily, programming him some signs and like chat displays. And then he also broke all of his screens in frustration. So not quite sure where that one goes, but fuck AI. We're using a book that's older than most of the people watching my show, including myself. We don't need fancy computer brains to go through and give us this information. We have everything we need here, and with some light Googling. So let's get this thing hooked up to 5 volts and ground. We're going to use 5 volts on this. It's ambiguous what the power supply is over here, but it does say a single supply source. So we'll use 5 volts, and I don't think that'll affect things too badly. Yeah, because it says VO is kind of the factor, and this is a comparator, so it's comparing to V input, or V whatever. So, been working on a local LLM chatbot project, knowing how to configure them and how to engineer prompts properly to get the answers you want. It's just, why are they called it like prompt engineering? That's not engineering. Shit. It's supposed to be a language model, so I'm supposed to be able to naturalistically talk to it, right? Instead of having to engineer prompts. I don't know. The semantics of it just annoy me. 90% of the population shouldn't be in the AI. Are you talking about like those swipe typing AI? Because that one's very frustrating. That one constantly gets rewritten, and every time it does, it's just dumber. It's just more frustrating for me to type what I want to type. Nothing's worked. AI is training on people. Think about it. Yeah, that's the whole George Carlin. Think about the dumbest person you know. All right, power to the chip. So pin 4, pin 8 are positive and negative, and we're not using one of the amps on this. And I forget how you keep it from running away. I think you turn it into Unity feedback, I think. Luckily, I am the dumbest person I know. I'm just going to shove this thing in here from the output to the input like that. And that should hopefully quiet down the other amplifier. Think about how you talk differently on the phone to get different responses. AI is the same. You talk to customer service people very differently than a coworker. I suppose so. I'd still give everybody the same information, though. Okay, circuit. Not too bad, not too bad. So we need a couple elements here. What are this? What is that thing? Wait a minute. The fuck? God, there's always something with these circuits. There's always something kind of messed up. Why is there always something kind of messed up on these circuits? What the hell is that? Is that a hot pepper? Do I have to put a hot pepper in a tube and hook it up to ground? Hashtag 48. No, it's number 48. What? Like, that's a chili pepper. Yeah, there it is. In the YouTube chat. What the hell is that thing? Huh? All right, let's look at the symbols of the book and see if we've got anything on that. Yeah, do I hook it up to a hot pepper tube? This book is not as comprehensive and complete as I think they state it to be. Like that symbol is not here. That symbol is not here. It's just a little squiggly thing. I don't think it's a Zener diode. This is a generic symbol plate that they just put on the front of the book, and then they didn't even bother to make sure that they didn't have things like a hot pepper in a tube in their symbols. All right, I guess we got to go to the source on this one. W. Zobel, a new current differencing single supply IEEE December 71 340 347. I'm not going to go to the source on that. I'm not smart enough. I don't know what that is. Spicy. It means, oh, it's a pretty hot pepper right there. Is that a temperature control thing? That could be what it is. But number 48. What is that? What could that be? It's always with these stupid freaking oscillator pieces of shit. Fucking, I'm so mad. Every single one is something that kind of just throws us for the loop. This is nice and simple. It had nice values. Everything looked like it was nice and easy to operate. The biggest one we have here is 1 mega ohm to VCC. Maybe they drew VCC a little weird by going down, but that's fine. All of this is easy. 100K, 510K, we got all that stuff. Or we've got multiples that we can make that stuff out of. That's fine. 500 ohm potentiometer, I got 10Ks. We could just be very careful with the knob. And then they throw us into this thing here, which I just don't know what the fuck this thing is. What is this? What is this? Usually you'd have like a squiggly line or just something that makes sense, unless this is some kind of a cutoff, but it's something to ground. Don't lick active circuits. Yeah, don't Don't eat your electronics unless you're purposefully swallowing one of those camera pills. Sine waves Weinbridge uses current differencing single supply op amp, that's this guy right here, operating over supply voltage range of 3.5 to 35 volts. So whatever voltage in we give it, it'll do an offset wave. Cool. And providing PP output, yeah, my PP does that too when I don't want it to. Providing PP output voltage swing of only 1 volt less than supply voltage. So VO minus 1 would be the swing. Okay. Special Motorola op amp used has 4 amplifiers on a single chip. I don't care. That's totally irrelevant. 4 amplifiers on a single chip, guys. Hey. Whoa. Look out. I don't care. Okay. TM Fredrickson, WF Davis, and DW Zobel. 3 people. 3 people were responsible for this. And we have a chili pepper in a tube. What is that? I mean, look, the way that they represented temperature control, like they have a particular symbol for lamps that they like to use, at least in a bunch of different circuits. So, you know, maybe they're not all using that lamp, but they all typically have a lamp that looks like that. And then for temperature, variable temperature resistors, temperature variable resistors. Sorry, I've got a lot of heartburn that I'm fighting down right now. Oh boy, that was very spicy. They will have a little bubble with a resistor in it and have a letter T right next to it. But number 48, chili pepper in a tube, I have not seen. Yeah, see, like this. This would be the temperature variable resistor. You got back Celtic runes. Yeah, no, it's indecipherable. It's supposed to be something else, and I think maybe there was a photocopying thing because it's so small on the page. If it was larger, we might have gotten a little bit of detail out of it and seen what it actually is. If it's supposed to be like a lamp, then... And I love how they have the symbols in the beginning here, and they're just as useless as Twitch chat. Could it be a thyrector? That sounds like something I got to go to a doctor for. A varactor. A pinpin diode. What the fuck? I don't think it's any of this crap. It's not a diac. And there's no way it's an LED of any kind. I don't know. This ChatGPT's offline. I don't care. Were you gonna use like the photo input one? Because yeah, this is like a printing error. It's not really even a printing error. It probably looked a little clearer if you look it up on the original thing. I had a chronic acute varactor once. You wouldn't believe what was switching around inside of me. For fuck's sake, like, can we just get like a normal one? Why am I having so much trouble with these? What is this a key switch? What do I even do? Should I just connect it? Or put a resistor in there? I mean, I guess I can look up the IEEE publication. I'm not good about that. So let's get some answers here. 1971 IEEE magazine or whatever. How about a new current differencing? A new current differencing single supply operation. Single dash supply operation. Operation. Oh, look, I get AI shoved down my throat even though I don't want anything to do with it. Although this is, in fact, what I was looking for, but it's also just right here. I gotta get rid of that Reddit button. I don't know what added that in. The one, yeah, I know the one you're talking about. Looks a lot like a key. Yeah, it looks like the thing I was trying to pick yesterday. But the one with the Arduino sticking off of the side for blog cred. 340 to 347, that would be the one. Where do I click? Applications to more optimally meet the requirements of the current differencing. 741, as a result of circuit simplicity, multiple op amps are possible, 6 independent, blah, 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 SPL, blah, blah, die. That's just about the chip. I'm gonna leave that alone right now. I'll figure it out. Well, okay, I just want to look at, like, I don't care about the text usage. I want to actually look at it. Do I have to pay somebody for this? PDF. Damn it. I'm not gonna sign in. No, I don't, you guys don't have to send me anything. It's okay. I know, I used to have a membership. I don't know what happened to my membership. I think it lapsed a long time ago. You know, I was just going to look through to see if we could get a little bit of clarity on what that component is. If we got just like a slightly better image of that. Because, like, there's all kinds of things you put in circles in schematics. And when you feed something from the top and the bottom with a circle around it, we've got a V in here. We have a weird symbol over here. We have a Zener diode over here. So I'm just trying to figure out what it is. We can build the circuit, and then I could just hit it with whatever. I could just put ground on there, or blah, blah, blah. Put the DOI here. Electricalsymbols.com. But it's like a blob. It's like a blob in a circle. All right, we'll do the Sci-Hub DOI. So I do this. Now I've got too much mouse wire. Then I put the DOI in there. Where's the DOI? There. And DOI is with the dots and everything. That seems like it's a little bit much with a slash on it. What do we did this last time? I forget. Yeah, so the whole Jiminy Jam just goes in there like that. There she is. Ooh, it looks like it's drawn by pencils. All right, so 300 and something or other. I think we went directly to it. Yeah, we did. We've got just the thing. So then our schematic, the one that this book took. What the heck? VREF. Bonk. There it is. With that oh so helpful chili pepper in a tube. Figure A. No. A. Figure A. B. Figure B. What the fuck? Figure 14A. All right. 14 pin. No. 14A. Figure 14A. Come on. Figure 14. Few averaging circuits are shown in figure 14. That's figure 14B. I need 14A. Oh, it's figure 13. No, it's figure 14. It's this one right here. 14 pin. 14 pin. You sons of bitches. Weinberg oscillator is shown in figure 15A. Oh my God, where the hell is this figure? It's like way, oh, it's beyond where it's referenced. Okay, 15A, figure 11, 14. Okay, so this is figure 15. 15 has A, B, C, and D? No, it's just not Where's the figure number? Where is it? Figure 15 oscillator circuits apparently goes A, B, and then C. No, it goes back to B. What? Oh no, it's vertical. It's vertical. Figure 16 goes vertically. Okay, it's vertical. I'm going insane. It's that one and the one above it. So it's the square wave oscillators, figure 14b, figure 14a is the Weinbridge sine. Okay, that's the one we're doing. Give me information, please. Let's go back up here. It's the same symbol. It's just as blurry. Figure 14, we want figure oscillator. Square wave oscillator shown in figure 15b. The basic Wien circuit has been slightly altered to allow biasing the output at plus VCC over 2 and to add the required input resistors that are needed to convert the nodal voltage to input. That doesn't tell us a goddamn thing. It doesn't tell us anything, and there's no reference to this symbol anywhere else. That is what a VN looks like. Those are square waves. What the heck what is this? It's not even like an attempt at a wavy line or a coil or anything like that. Number 48, that we saw everything. Number 48. There it is. It's the only reference. That ain't no coil, I'll tell you that much. A switch? Switches look different than that. A pilot lamp. Usually they do like a squiggle or a loop of some type. Are there any lamps in any of the other don't have lamps anywhere else? Looking. Not finding. Certainly isn't that. Current mirror. Man, of all the things, you know, it's like this one looks beautifully simple. It had no super. Yeah, it looks like a feather tickler. Like a goddamn. It's like a sex toy in a tube. There it is. What do I do? What is it? I made this circuit as a child. It required a flashlight bulb in that spot. Really? I don't. Do I have any bulbs like that? I used to. I had a bunch that came out of my car dashboard. That would have been good to use in this one if it does actually require a bulb. Google image search for that? I don't know. I don't know about that. Hold on. Number 48 bulb would be our best lead from Pseudo's comment. And it looks like the number 48 bulb is in fact your common. Use these a lot in older circuits, so it would stand to reason that it would be some kind of a bulb. And for some reason, IEEE has done a complete departure from the typical bulb symbol. But number 48 would be like your, yeah, like a little desk lamp kind of thing. Well, they use stuff like this a lot in like 1970 circuits, and like this is kind of a bastardization, like bulb schematic symbol. There's a bunch of variation on it, none of which look like a red hot, not red hot. They just, none of them look like a chili pepper inside of a tube. You know, the closest I was thinking is you could get one of these little loopity-loop things that they typically use, and this is the one that's preferred by the rest of the publication. But usually you would see a little curly Q inside of there. And in our case, what we saw is a blob. Number 48, vague familiarity. Looks like the top right one. With an X. Wow, what a great first message. Just thank you so much for this contribution to our stream. You've really helped boost us by allowing me to buy viewers. Fucker. Hate those things. Bleh. Yeah, we've already got all of the cheapest viewers here. You're absolutely right about that. All the way top right. Like just a little bump. It looks like their pen slipped when they were trying to draw it, and it put like a blotch of ink down. That's all I can really come up with, because it's asymmetrical, and it's just got these blobs. So like either that or like the 2-bump version. The bump-a-bump. Anyway, do I have a bulb? We took apart my car dashboard, and did I save those lamps? Because they were kind of neat little lamps, and those would probably have similar properties to whatever I have to put into this circuit, but I don't know if I saved them. May not have saved them, in which case, how do I do like a little cheapy little bulb? It's not something that I have around here, because LEDs are the future. Yeah, in my Easy Bake oven. I think my real oven uses a lamp, not a bulb, but I'm not going to go into my oven to try to make this thing work. A light type bolt through a circle. Yeah, I guess it's just it's so clunky. I think it's a photocopy error or a pen leaking. Pen leaking would be the closest I could think. There's a fuse in here. Grain of wheat bulbs. Huh? No. No, I don't think I have anything like that. Maybe. No, I don't think I got nothing like that. Where would something like that even go? Let's see here. I'm looking through all my bins. I'm just going to see if we do a sweep and if I can uncover any incandescent style bulbs that I might have. Oh, lightning bolt. Lightning bolt through. I guess that would explain, yeah, why it's thick on the top and thin on the bottom, because it was supposed to be like a lightning bolt. That does make sense. Why it would be a lightning bolt symbol is beyond my beyond my ability to reason, but oh, so close. Wait, this might be one. What the heck is this? It's like a hold on a minute. That might be exactly what we need. Hold on. What, do you think it's the where the O-scope should be measuring? Oh no, there's already an output. No, but that being like a scope, I don't know. Okay. What in the heck is this thing? On a number 48, but it does have 2 leads on the back end and then a big thingy. Let me put it on the diode test to see if it's in fact, if it's an LED or not. Wonderful thing about the diode test all kinds of different things, and you'll know if it's a diode or a lamp. Diode will have a voltage drop across it. Lamp will just be a resistor. There's dog hair on this thing. I should have wrapped it up. Yeah, if we need an incandescent bulb, I don't know if that's going to be a deal breaker or not. I don't exactly have a number 48 bulb. It's not like I couldn't just like get one, but what we're trying to do is build a simple circuit here. And I've been failing at it so much. Okay, that's lighting up. This is on diode. Yeah, 1.8 voltage drop across it. So this is a diode. This is a diode. It's a cool little LED. I don't know where the hell this thing came from. Where'd you come from, diode? Because you're kind of neat. That's a nice like indicator panel. It looks like HAL, actually. And no, we're not going to just like simulate these circuits and stuff. I know you're using sim for symbol, but like the audacity of the chat member to suggest that I put this into a simulator. There's a little HAL bulb. Look at this thing. Sorry, my leads aren't. Sorry, Dave. But I'm afraid I cannot do that. That's cool. That's a neat looking thing. Where the hell did this come from? It came out of something. But it's sort of this ghostly little red light. Pretty cool. Where are you going, Dave? Daisy. Daisy. This is an LED. It's got a 1 point something or other, 1.4-ish volt drop across it. 1.8. It's almost got a 2-volt drop across it. It's an old LED, I guess. But yeah, this is definitely an LED because otherwise it wouldn't be lighting up. If I put it on resistance, it shouldn't be reading anything. Yeah, it reads in the mega ohms. So yeah, it's definitely a diode. Okay. Not a lamp. So if I were to find a lamp, I think I got rid of all of those lamps. That sucks. I thought I had a lamp. I don't have a lamp. Cool little diode. I'm going to put that over here. Actually, I'm going to put it in here with all my cool stuff. All my cool stuff is in here. There's all the microcontrollers and the breadboarding, digital breadboarding stuff. I mean, look, we all can relate to brick. You find a really cool lamp, like, that's a great lamp. I really appreciate that, you know? I love lamp. I know he was just naming stuff in the room, but I need to go off on a bit. I don't have lamps. It's not something that I keep. Actually, I really don't want to steal one from over there. All my Star Trek Christmas ornaments are sitting over there because I need to fix them at some point. We need to like get into them and fix them. There might be a lamp in there that I can take. Although most of these have exploded. Most of these are like dead because of I don't know, probably a power surge. Ah, my lights! Ooh. This is what I get for hanging my mic cable on the lamp so that I have easier movement in my little area. Is when I go just outside of that area that the lamp will topple over. Take the blinker out of your car. I have spares. I have well, I'm not going out to my car. I'm not going outside because the sun will obliterate me. But I do have lamps in my car that I can use, not actually sacrificing the lighting of the car. I mean, like I have spares in the car. Wait a minute. The car bin. Oh, you may have solved this. I have these big bins that I forget about. One of them's filled with car stuff. Of course, one of them's filled with milling stuff too, so it's really heavy. But if I can find the car one, that's audio cables. Any lamps in here? No. Never follow an engineer to a second location, chat. Ah. Oh my god, this one's heavy. This one is not car parts. Actually, I think I cleaned out the car parts one, but there might still be a lamp. That's gonna be this one. This one's gonna be real heavy. Oh, that's not that bad. No, dear God, it is. Okay. Ugh. Okay. An incandescent lamp would not survive in that bin. Whew. Okay, let's see here. No, mostly machining parts. There's a couple car parts in here. Like, you know, one of these. But nothing quite like what I'm looking for. It's all screws and interior clips. No lamps. Darn. I need to be like situated on top of a warehouse in order to get all the parts that I need for these things. I mean, electrical engineering without a lamp, you typically don't need that kind of thing, but what if we found lamps in stuff? I think it's only the one example that I have is of the car stuff having an actual physical lamp in it. They're more and more rare these days. You can still find some things with like an incandescent lamp, but it is getting much more rare, lampless. What's an equivalent? The old circuits had to get creative. Well, they, you know, all they had is lamps, but it was always cool when they would use one for like not light output. They were not using it for light output. What's in this one? My vacuum tube bin? I don't think I'm going to find it in the vacuum tube bin, but... Oh, I know it has a lamp in it. Oh, no, maybe not. Hold on. Ah, avalanche. Partial avalanche. That's what I get for stacking shit up. All right. There was... that's where I found a lamp. It was one of the one of the indicators. One of the gauges had like a lamp built into it, but I don't think it's one that I can sacrifice. The filament of a vacuum tube. Well, I do have vacuum tubes right here. Some of them have filaments in them. Hey, y'all got a filament in you? These do have, I believe, a filament. The question would just be what pins it's on. It wouldn't be tungsten, it would be a heater. Ah, yeah, that's true. That's true. Slightly different from what we're looking for. I have a lot of Nixie stuff, and it would be nice if we could use it at some point in a project. Make a cool display of some kind. Am I really going to fail again in making something just simply oscillate? It's looking like I am. Nixie clock. I don't want to just make a clock out of them, you know? And I've also got that desktop Nixie thing that's like it's like a DRO readout. It would be fun to be able to put that to something. Something that's not just reading the time. Viewers, things like that. Like I could make a panel that reads that stuff out. There's a lot of stuff we could do with stuff like that. All right, let's see. We're getting deeper and deeper into the archives here. Deeper and deeper into the archives to look for an incandescent bulb. Something that I could clearly just find elsewhere if I were more resourceful. It's something that I should have like one of in a drawer, right? Like I should have one just for when I need it. I'm not taking it out of an appliance, thus rendering the appliance more annoying to use because it doesn't have a light. Let's see, I only put laser stuff in there. What the hell is that? Laser stuff in here, right? Yeah, this is just laser stuff. Mostly. There's some other things in here. Some slight other things, but not much. Oh, those are the legs for my laser table. I should get those where they belong. Nope, nothing in there. Okay. Lamp. So hard to find a lamp. Is it so hard? Those are all screws and stuff. Okay. What the heck was that? I just bumped a bin up against the big thing here, and at the same time, I think somebody slammed a door. So it seemed like I caused all of this atmospheric thudding to go on all at once. What about the speaker stuff? Did any of that stuff have a lamp in it? Hold on a minute. What about you? Speaker stuff? I don't think any of this stuff had... I think it had a driver that could do a lamp. But the audio stuff, some of it had like... There's those VU meters, I think, had a lamp on them. None of that stuff is lamp related. Shockingly enough, there's nothing in there. I don't have a lamp. How's that? That's embarrassing. I'm embarrassed. This is unacceptable. An old flashlight. No, that one's LED. Holy shit, I don't have a lamp. We got Christmas lights with lamps in them. A lot of these are LED, though. And you can't get into them to get the lamps out. Because I need to replace a lot of the lamps in these because they've melted the plastic and gotten damaged. What about the Spock shuttlecraft? That one's snapped together. They're all snapped together too. They're insidious little things. Holy crap. Well, I don't have a lamp. I'll have to go get a lamp at some point and bring it back over here and just have it for any kind of a breadboarding circuit thing that we would do. That's incredible. So we don't have a lamp, so we can't build the circuit. That's a weird place to be. Everything else about this was super reasonable. let's keep going. Let's keep moving. We're getting caught up. I mean, it is fun to look for stuff in this veritable garbage pile of electronics stuff, but yeah. I don't know. It's crazy. It's crazy. We haven't been able to oscillate. Part of it's not on me. A very small part of it's not on me. Some of these circuits are a little bit weird. Used to be everyone was throwing them out. Incandescent Christmas lights. We've got some. I don't have any in here. We have some. That's what all the Star Trek ornaments plug into. I got a big pile of derelict Star Trek ornaments up there that suffered a power surge. But the problem is none of them have the lamps, and the lamps are in storage, which, while it is, in fact, a lot closer than you would think, the other side of that wall, it's very difficult for me to get into to get them out and get a bulb. I am closer than anywhere else in this house to those Christmas lights, and yet it would take me too long to get in there to get the specific light. They're buried in the back of like a storage closet, and they happen to be on this side right there. I could punch through this wall and get to them. I don't have operation, no. That's crazy that I'll get a lamp for the next time we I don't know if we'll try oscillators anytime soon, but now this is actually gripped my fascination, because it's so simple, but it requires a lamp in order to create like a heat bias or something. You know, you heat up the tungsten filament and it changes depending on, it's such bullshit. All right, can we oscillate, please? Something. 1,000 hertz. No, this has a coil in it. Put relaxation, programmable unjunction. This is like AI. It's another wine bridge with one eye. Why do they draw them like that? Yeah, a lot of these are like homework problems that they did. Put relaxation, programmable unit junction transistor serving as a trigger in low frequency relaxation oscillator. Put relaxation, unit junction, relaxation. Huh? It's a weird little circuit. 20 volts. All right, we gotta find something better than this. Yeah, they're slightly thick op amps, right? The Hands of the Souls. A nightlight lamp? I don't have it. No, I don't have anything like that. I mean, where else, you know, where would you find a lamp this day and age? I think they do seal in the soul of one engineer per book, because this is a 300 euro book apparently. I don't know what the newer editions are like, but yeah, I think they require a human sacrifice in order to create a book of such strong magics. Wine sine wave oscillator. That one again is using another set of Zener diodes in a weird way. It uses a regular diode and then a Zener diode, and diodes are tough. It's tough to figure out what diodes I'm supposed to use. I have diodes though, so we might be able to do that. I do have also a bunch of Zeners, so that's also possible. But then we have a 2N3819. That might be generic enough that I'd be able to source that. But again, we're looking for simple here. We're looking for something that I can build. Look, it's not that I don't have a wealth of electronics capabilities. It's that I don't have a wealth of 1974 electronics capabilities. Some of these parts are generic, but they're not really telling us where the Jelly Bean parts are. If we have a generic part that can be replaced with, for instance, like a 2N2222, that requires us to look it up a little bit and figure that out. We have to kind of transport ourselves all the way back to this era of of building stuff, and I have been a very digital shop lately. We've done a lot of very digital things. Even my analog oscillation things that were successful are digital by nature originally. They have a microcontroller on them. So this is part of the struggle here, is that we're trying to build stuff from a bygone time of analog electronics. That's part of the challenge, part of the fun. So yeah, I won't be using ChatGPT, and I will not be simulating anything. I hate simulating so much. So much. This one looks possible. We have a single op amp, generic diodes. They're not even labeled. And a couple resistors. Basically, this is part of that the 2 amp circuit. And the question is, could we build this with a reasonable voltage? We're not really given the voltage input to the op amp on this. That's what was so alluring about this one too, is that this one functioned at the voltage we wanted it to. Is this 6 to 36? Was it 6 to 36 or 3? Yeah, 3.5 to 35 volts. That's the beauty of that one. But it requires a lamp that'll heat up and cool down. So, so here we are. Take another sip of liquid. I'm desiccating myself by talking so much. Of the 64 planting bins that I planted with seeds, several of them had slime, like green slime in them. And then one seedling is sprouting up. One single serrano pepper. Yeah, it's more than likely that that's the operating voltage of that specific amp. It's 3.6. Whereas we were going to use the MCP 6004, which is like 1 point something up to 7 or 5, 6. I don't know. Only single op amp, keeping component costs at a minimum, yet distortion can be kept in range of 1 to 5% by adjusting carefully. Circuit has high output impedance and changes in loading affect output amplitudes. It should be used with flex load or with buffer. What the fuck does that mean? R1 is the same as R2 and C1 is the same as C2. Okay. With values determining frequency matching of diodes. Well, with values determining frequency. Matching of diodes minimizes distortion. Do I have any through-hole diodes? I don't think I have any through-hole diodes. Put my single seedling pepper in the pepper tube. I'm sorry to have to sacrifice you, little one, but you survived. Yeah, I guess I could build this one. I had a couple diodes that I made. Here's one of them, I think. This is a capacitor. I had a couple diodes that I made for this stuff. I should find them. That'll make this a little faster. Yeah. I have a curve tracer, though. I have one. I bought one. It's a little circuit board that you hook up to the oscilloscope. Just for this very reason, I got a curve tracer. Theoretically, in here, there's some diodes we can grab. Let's try to build this circuit. It's so simple. And we've already started on it anyway, so I'm going to need the millimeter, the multimeter, and I'm going to need to put this way off to the side. We're going to build this one. Hopefully I'll succeed. What's this, 50K? Yeah, we'll use the 10K there. I might have a 50K, actually. I think I have a 1M. Where'd the knobs go? This thing's starting to smell more like a book from the 1970s, which is a good smell. It's actually a good smell. The book smell. The smart people smell. Let me try to find a 50K potentiometer. I have a 1M, but I think one of these is 50. That's 1K. 10K from the UK. 10K, again from the UK. This one's a 1M. And then these, I believe I'll have, it's 10K. 100K. One of these 50. Knows it. No marking. No, there is marking. Hold on, I gotta sit down. Get my face closer to it. No marking. Oh, there we go. 203, so 20K. I know one of y'all is a 50. 500. Oh, come on. Maybe it's in one of these over here. There it is, 50K. All right. It's all the way over here. Any other shocking things about the circuit? No. Okay, good. No, nothing weird going on. No, like, oh, we decided to put a rock on this piece here, so you're gonna need a rock. What? Huh? I need what? I will get something oscillating, chat. I have to. I can't fail. I just can't. All right, I'll get a 3-pin header on this thing, and then that'll interface it into the board, and we'll have 50K instead of 10K. We'll have the actual value of the thing they call for once. The actual value of the thing. This right here. Bring this over. Get a 3-pin. I got lots of little 3-pins because of that LED project. Plug that in for heat relief. Turn on the iron. Iron. Got a good tip on there. Get solder. Probably should use the big solder for this. Whatever. Use a little solder. Just use more of it. Twice the amount. Ah! It broke. It always does that. Okay, I'm going to pre-tin everybody. Actually, no. Pre-tin just the one. Don't even need the scope for this. I just need to line it up properly. Try to have this facing a little bit upwards, I guess. Real test of this book would be to find like a soldering iron burn on it. I'm going to flatten these out. These were bent specifically for the soldering that I had to do for that big theater globe. Really flatten them. Good enough. Good enough. Let's just get this done. Actually, I'll do it this way. This will just have it be nice and flat. Be able to. I can adjust it on the board, and then that'll be fine. It'll be backed up by the other thing. God damn it! Stupid. Oh, what's going on here? This got all bound up. That's why I was ripping and tearing. What happened here? This is my beautiful solder reel thing that never did me wrong once. Until I put really sensitive solder on it. Yeah, it's supposed to put up almost no resistance when I'm unspooling it, but for some reason, something happened with the spool of solder. Hold on a second. Yak shaving. Always gets us. Yeah, something over here is messed up with the spool. Whoa. Alright, that should be good. When in doubt, I guess you jettison a bunch of solder. I'm going to put that aside in case I need a big puddle of solder for something. How much is this? Jeez. It's a pretty big chunk. Alright, well, if I ever need a big pool of solder, I got this sitting here. This feeds back through. We continue with what we were doing. There's always a little even just the smallest little yak to shave. But I'm here for it. I'm here to shave it. Heard there was a yak that needed shaving. Okay, got that. Now, any of these little pieces of solder that I got sticking around. This stuff is very thin. I got it for surface mount stuff. And if you don't have, it doesn't have like the ability to resist the spool as much as you would think. So it ends up breaking more easily. If any little thing is wrong with that spool. Okay, so here's our 50K. And that's ready to go. Now, we were using only one, so I've got the other one sort of looped off on itself so it doesn't end up cascading out of control. I don't know if these do that or not, but it's just something that I've seen them do on those. So now we add a bunch of components. So R1, R2, C1, C2, I don't even have with values determining frequency. Matching of diodes minimizes distortion. So we're looking for a couple diodes. Do I have a couple diodes in here? I think I do. I don't know if I have through-hole diodes immediately, but I do have diodes that I put on adapters. Like this here is a capacitor. These are all just the things that I've pulled out of other... Here's a diode. That is a CAN diode. Do I have two of them? Two of the CAN style diodes would be ideal. Here's another one. Okay, cool. So that's two diodes. Good. These are the old school surface mount ones that I've soldered onto through hole things here. You can see them right here. Where in the hell? What in the goddamn? Yeah, just like this. It was just soldering it to the two posts. I should have used the female header on this, though. The female headers are much easier to solder like that, but you can just see what the component is right there. So on this one, we have on the output of the op amp, we've got the two diodes and a 10 kilo ohm resistor. So this op amp right here comes from pin 1. Let me just close this lamp thing. I'm never ever going to need a lamp. Should I buy lamps specifically for that? No. Maybe I should get a car light and bring it in, like a car lamp, not light. So anyway, we've got a diode here facing one direction, and that is going to be on pin 1. Is going to go into the anode and the cathode of a set of diodes. So I need them facing opposite directions right here. So there's that part of the circuit. That's up here. That's this. This is as simple as it can be, and I'm gonna be very curious to see how we fuck this one up. By dropping all this stuff is what we're gonna do. Yeah. There we go. Okay. It could hurt to have them laying around if I like step on one. Like that's gonna hurt. Great. Let's put a crease on the page. All right, 10K across those. So that's going to be one of these big things. Those are 100. These are 4.7. These are 10. Okay, the 10s are all split up. It's terrible. So do that. Bend it downwards. I need that curve tracer to be just like ready to go, just so I can run it. I can match components real quickly. So throw this thing in right like that. That's that whole portion of the circuit, built but not connected. Now we go through the 50K pot to on the other end of the diodes and the resistor. So we go through the 50K pot, and I'm out of holes. Which is something I said the last time I went to. Anyway, that has R1, and then this also goes to, oh, that goes to the, wait, that goes to the negative. Oh, the problem with doing that is that I could put it in here, like, just put it in like this, but then I've got that other pin that's not supposed to be connected up there. No, that's actually not how this is supposed to be connected anyway. It's supposed to be connected to the other side of the diode, and then back to, so yeah, we'll go, well, actually, I could go over here. That. Now I've got my adjustment knob right there, and then I do a yumper. Oh, I see. The other one here goes to ground. Okay, so that's easy enough. This one goes to ground. Let me get these resistors out of my way. Grab this right here. Ah, sorry. Trying my best. Doing my best today. It's not good enough. So ground goes to here. I've got ground wired up on the board to everywhere it needs to go. Positive power does not go to both locations though. So if I have to get positive power, I have to go to the other side of the board. But this does have ground. So ground goes right there. And then the wiper goes to the minus pin. So it's output minus plus. So minus right here goes to here. So that's nice and clean. Well, the problem being that I don't have a jumper of that specific length. I remember that I don't have that. It's like all these jumpers are all annoying. And bend these in a little bit, maybe. Yeah, do I have any of like those fairy lights? Those were not incandescent. That's the problem with that. Those were just warm LEDs. I'm going up like that just because I don't have anything that's slightly shorter than this. So these resistors are really, I'm gonna have to find a big pack of larger resistors and order that, because boy, these are just really getting on my nerves. So the plus, and it goes minus plus, right? Yeah, minus plus. So we got the minus on there. The only thing we're missing is R1, C1, R2, C2. And those go to the positive in two different ways. R1, R2, C1, C2, huh? So what is a value that we think we could actually put in here in order to create proper oscillations? The other ones had, let's base it off of one of these other circuits here. They expect us to know the equations just automatically, don't they? So over here, the circuit that we built earlier, R1, R2, C1, C2 would be 0.222, 0.122. So let's do 0.1 and 22, or the, what do we have? We had like 2 point something or other M. So we'll use that value, and I'll use the multimeter to measure them. And then we'll use the 0.1 ohm 203s. 103 rather. Or we could use the 102, the 0.22. 0.022. We'll use 0.022. Okay, so one of them goes from the resistor to here. Oh God, how are we going to do that? The value of the resistor being one of the 22s. So let's measure this out and make sure we get the right thing. Might make our oscillations very slow, but this to ohms. You guys just get the whole view of the whole thing then. You get to see everything. Okay, values that I've already got on the field. Go to ohm here, wake this up. Go to 2 pins, and then insert the resistor. We're going, oh God, can't control anything. So this is the 10M. M. Okay, so we'll use the 2Ms. So our first one is going from, we're going to the plus, so I guess we can jump this way. That one goes to the capacitor first. Hold on a sec. So we're going from the caps and the resistor from the non-output side of it, the non-potentiometer side of it. So that would be this inside piece here. And I kind of want to go out to here because then I have room for stuff. But this is a little bit limited. So we're going from here to there. I'm going to just not short out that one line. So there's our 2.0 M, and then that then goes through C1 to the positive differential. So that would be from here to there, just like that, there to there. The negative differential goes to the wiper of the pot, correct. And then the other part goes to that junction between everything. Why is this becoming yet again another completely bonkers? Okay, so we have one more RC to ground that goes to this pin. Oh, good. We might as well just take ground and put it up to this because we have a C to ground. We have acetaminophen. I mean, a C to ground. Motion at the front door. Oh my God. Well, that goes to ground. I guess I could do it like that. But then there's another component that I have to fit in there, which ain't gonna fly. Oh, that's the wrong one. Wait a minute. It's an RC to ground, but the problem is it goes from this pin, which would make it really easy if we were doing surface mount electronics, but it doesn't make it easy here. So I'm gonna jump over it and then have another ground next to it. It's like that. And I can put the resistor there too. If I can find the other 2M. 2M. Try to find it. 46K. Oh. Yeah, this is it. Problem is the other 2M's not going to have long enough leads for me to do the stand-up resistor. 15K, that's not it either. It's this really long one. Come on. $32K. Where's my resistor? Where's my 2M? Is it safe? $1.9. There we go. Okay, so here's the other two. My only problem is I don't think I can get it to go across to where I need it to go. So wait, this one goes there to there. This needs to go out one more pin. I just need to spread these a little bit. That, and then now we go from this outer pin to this positive pin. That, and then I just need to do a ground here. So we'll get the most ridiculous, just whatever's in front of me. Let's do whatever I can to get the circuit done. And maybe now we won't get embarrassed by our inability to make something oscillate. Okay, right there like that. So we have an RC going to ground. Then we have a C and an R going back up to the, what pin is that? The other side. So the R goes to the other side. That's the wrong side of the, this would be the output side. I think I need it to go to here because that goes, this one's the R1. Yeah, okay, so that's in the wrong pin. Boy, the ease at which this thing just gets removed from its seat is really annoying. The clips barely make contact, and I need thicker resistors to do these jobs. There we go. Okay. So now that basically goes from the output of the op amp, which is here, it goes to the potentiometer, which feeds it back into, well, it has between ground and negative minus, this is output. Output also goes into the diodes facing both directions with a 10K across them, which is this extremely loose 10K. And then we are measuring that at that junction. So we're going to have to get an oscilloscope in here. Let me use like a jumper for that. Actually, I think I can get a the oscope jumper in there. Let's try that. All right, we'll power this up in just a second. It is a pretty simple circuit, but oh yeah, see, if I do that, then it's going to short out. Ah, come on, man. I need something that's got like a close jacket around it. That's not going to do it either. Are you kidding me with this? Did we find lamp? Maybe we're close. I could just touch the probe on this. I'll just touch the probe on that when the time comes. So we'll do that, and we'll take the hat off of the probe, and then I'll go back to this view. And then we need to do grounds and powers. So power to power. We don't have a VCC on that? No, it's all ground. Okay. Ground to ground to power to power. And then this gets ground. Okay, so even simpler oscillator. This one should be super duper simple. It's like 5 components. Hopefully it works on 5 volts. I would assume so. Let's just see if this thing actually functions. So I've actually got 5 volts outputting right now. So nothing heated up. We got that going. Scope is where? That's here. Of course, we don't get anything on the output. Pin 1 should be, oh no, we're beyond, we're actually at pin, oh, our output should be over here on the non-ground pin, so that's here, actually. Oh, but that means that R1 is connected, wait a minute, there's a bunch of wrong connections here. Hold on a second. I think that resistor was actually connected correctly originally. Hold on. Because that one goes between, yeah, it was connected incorrectly. All right, it was connected correctly originally, so I need to move this one back, and then we can still use that pin junction as our output. So that goes there. Now that's correct. And now I can actually grab a lead wire for the probe hat. And that'll go right here. And we should see oscillation, but these circuits have been burning me, and so I don't know what's going to happen. Turn on power. Adjust. Okay, some funky stuff is going on there. I think it's mostly just me touching this thing that's setting it off. Bob it up, funk it down. It's something I'm doing, right? It's something I'm doing. It's got to be something I'm doing that's causing this. For real, for real. Why am I screwing this up so hard? You know, I think it might be these resistors. Because they never seem to quite make a connection. Oh god, I'm clicking again. Stop clicking. All this clicking that I'm doing. So all the grounds that I'm picking up over there are represented. I mean, if I take ground and I connect it over here. Well, now that's just noise. Connect ground over here. Oh, I see. Ground over here popped off. There we go. That doesn't fill me with confidence. Yeah, that's components slipping out. This is filtering stuff. It's the pepper's fault. We should have put in the pepper. It could be my RC values too. The 2.2M versus 0.1 UF might be totally wrong for this circuit. But we still haven't been able to get anything working on this freaking book. Oh my God, I'm so mad. Okay, next Friday, we're going to return with the book again. This time I'm going to have a lamp, and this time I'm going to be mad. This circuit doesn't have a lamp on it. But I don't have lamps. I don't have lamps just sitting around. So next time, I think we come back with a lamp, or I find a different circuit. Oscillating voltage values is one of the basic tenets of design in electrical engineering. It is one of the things that you should be able to do in your sleep, and I can't even seem to manage to get one circuit to do it without me injecting noise from my misgrounded body. I do not understand. No, these are relying on wine bridges. Yeah, these use wine bridges, and I don't know, they should function. I think it's down to the RCs that we chose and the fact that things are getting just a little bit janky on this breadboard. I think things are not exactly connecting properly. I need to source, like, that looks almost like it's oscillating in some way. I don't think it's down to the diodes. I think it's just the specific, like, just the connections that I'm making on this board are just bad. If I soldered this down, I bet it would work. Better choices about components would be something that we should do. One of the things we're learning about this book is that a lot of these circuits are fairly malleable, and they're not exactly well represented, and the values are sometimes not there. Even if you look them up, they can just be like, well, whatever. So I don't know. We're going to have to figure something out for next stream, because if we do this again, I don't want this to just be another unsuccessful attempt. I need to make sure that I'm going to succeed. But the thing is, I will never pre-script anything that I do on this show. In fact, I barely know what I'm going to be doing on Tuesday. But I think I need to wrap up around here because I'm starting to get very frustrated. I'm going to try to get the right kind of resistors for this board, because if we're going to be doing more breadboarding, I need to have the ones that actually make good contact. Different breadboard, or move it over and see if you have better. No, it's every single connection location on this board is bad because of these quarter-watt resistors. These precision quarter-watt resistors that you can very easily get in a pack. They're cheap because they don't use a lot of metal, and the margins for things like this are very tiny, but they don't use a lot of metal, and so they're too thin. The leads on them are too thin. They barely make contact, and so whenever I breadboard something, I have this frustrating period of time where I'm going through this kind of stuff, where I wiggle the IC or I wiggle the component, and I touch this and I poke that. I don't want to have that. We need better resistors for these things. This is just not working out. That's what I learned today. I hope you guys learned something too. I think that's going to be it for me for the day. My eyes are starting to cross. I'm getting real fucking frustrated at these stupid things. Yeah, listen, AI is not, stop with the AI. AI is not going to solve all of our problems from on high by being some kind of an uninterpretable, unpredictable, stupid computer thing. Yeah, I'll find bulbs. Find is the better option. I'll see if I can dig up a couple bulbs. There may be some at the bottom of the Lego bin. Actually, if I still did have my collection of Lego, we had those little blinking lights that were lamps. Those would have been perfect. Actually, what would have been perfect if I kept the incandescent bulbs that we had inside of the BMW dashboard. Those would have been perfect for this, because we could have put them up on just a little pin header. I'll find something though. I'll find a bulb that I can use so we can go back to 1974 and actually build something that oscillates. But I got a week to do that. I have uploads to do tomorrow, so I'm not going to be streaming. We've got 130 to go. They're not going very quickly these days. I'm going to try to bum rush and get as many done as I can, and maybe I can actually get ahead of myself for once. And we'll come back on Tuesday, and I don't know what we'll work on. Probably burn the subs. It seems like we kind of have to do burn the subs now. I'm going to figure out some wiring stuff, some hanging of tubes and things, and we'll get that done. Until then, I'm closing the book of 1975. It will be opened again on Friday, and then we'll do some actual stuff again. I keep promising that, but I'm gonna get it done. Voyager, you came here at a hell of a time. I'm just wrapping up. I'm just now wrapping up. It's good to see you though. I've been on for only 4 hours actually, so that's a good amount of time. We didn't get anything done today. You didn't miss anything. I tried to build a couple of these 1974 circuits, and they just all have these little curveballs. We had an electronic symbol that looked like a hot pepper in a tube. Ridiculous. My dog's barking at something, so I'm gonna go see what's going on. I'm gonna go touch grass. You guys should do the same, and I will catch you guys on Tuesday. Till then, here's all of the social media information, including Discord. And if you, damn it, son of a bitch. And if you need to get clickable links, you can come over to Twitch for it, or you can just do like !Discord in the Twitch chat, and then I'll give you a link. I don't have any of the bot stuff set up on YouTube though. But yeah, anyway, I will catch you guys later. Maybe you could write that down with a pen and paper. There you go. And I'll catch you guys later. Woo, 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 woo. The dog's barking.